It is.
Nice trying.
Yay!
Come on,
It's
congrats.
working.
Yay. All right.
Yay! I always wait for it to show up on my end first before I close it back out. But yeah.
All
Okay.
right.
We're
Cool. Cool.
live. Okay.
Yeah.
It, great. Okay, so I can get rid of that. And I usually give it a minute or two because YouTube has like a little bit of a delay on when it lets people in.
Yep.
But
We're good
so
on YouTube.
yay. Okay.
Cool. I'm gonna dim my lights a little bit.
All right.
My lights in the background are maybe a little bit distracting.
I
So
don't, and then of course I'm on the road as usual when this happens, so I don't
you're
have,
in a you're in a hotel. Wow. Well, you're
yeah.
getting, to be honest, you're getting really good like connection and stuff
Well, that's
while
good. Yeah.
yeah.
So
I'm
not
quite
bad.
impressed. Yeah, I'm impressed.
So I
But
usually do like I try to put the backgrounds like this is Detroit. So it's like so when if I rewatch it, I'm like, oh, I know where I am.
that's
So so it's fun. But
that's
anyway,
great.
we'll get rolling here. So thanks for joining everybody who's online that I'm not looking at the chat because I don't have my dual screen set up.
All right.
But we have a very special guest today, Dr. Tamitha Skov.
Hi guys. I guess
Hi.
I came at the right time, I think.
Yes, yes, you did.
Yeah.
And I have an intro here, but I need to find my screen for it. So hang on. So I will read about it. So I mean, most people watching probably know who you are, but we have to, it's the whole formalities of it, right? So
I wouldn't necessarily bank on everybody knowing who I am. They're like,
I yeah,
who's this
yeah, I
chick in a
guess you got a
red
point.
shirt? And other people are going, red shirt, red
Yeah,
shirt.
red shirt, red shirt.
I made sure to wear it for that reason, just in
Yeah.
case, just in case.
All right.
Uh, Crazy.
Let's see. I'm gonna see if I can maybe we'll condense it a little bit here. But so Dr. Skov holds a BS degree in physics and physical chemistry, as well as a master's and PhD in geophysics and planetary physics from the University of California at Los Angeles. Good old UCLA. She retired from the Aerospace Corporation in Los Angeles after nearly 20 years as a senior research scientist in the Space Science Application Laboratory and the Material Science Laboratory. And then in 2019, she joined Millersville University as an adjunct professor, which we are all part of this program here, and created the core phenomenology courses in the space, weather, and environment, or SWEN graduate curriculum. And let's hear her forecasting work as space weather woman is widely known on social media with over 6 million views worldwide. Tamitha has been featured in popular science magazine, MIT Technology Review, The Scientific American, and other high profile magazines. And you've also appeared on the Weather Channel, History Channel, BBC, Fox Weather, NASA TV. So yeah, you're quite the uh, media person, which we all appreciate because, this is quite important. So I think I've told you many times the way that you handle a lot of these subjects has been probably the best I've seen.
Thank
You
you.
know, yeah, dealing with these complex things that, people without a science background like me can grasp pretty well. Being more of a visual person. So I appreciate that. But
You're very welcome.
yeah. And speaking of, so before we get into our questions, we should probably talk about the elephant in the room of what happened about what, 4 or 5 hours ago?
Yeah.
Oh
A few
my
hours ago. Yeah. Yeah, and
God.
I'm not sure it's even an elephant in the room. It's more like if it is an elephant, then it's a mama elephant and about, three or so babies.
Yes.
Because there are pieces and parts to this thing. And I'm not
Yes.
even sure, the last time I checked stereo imagery for the coronagraph, I'm not even sure if the stereo imagery is completely in yet. I mean, because
Uh-huh.
this thing is literally in the stereo imagery for coronagraphs, it's completely covering the entire plane of the sky right now. And it's, the last image I
Yeah.
saw. And we'll see, because it looks like there's still more stuff coming off.
Oh,
So this thing could be a lot more interesting than we might be
okay.
led to believe. So
Yeah.
I don't know how you want to, how do you want to, what
Yeah,
level of
tackle this.
detail do you, yeah.
Yeah. Um,
To be
I know
honest.
that's a good question. It's like I guess maybe we just go over some of the images because like for me what would be cool to see is how like I was looking at how a lot of it looked like it was deflected, but not really. Like maybe we can kind of go over like why that is,
Okay.
um,
So
which I
yeah,
think would be helpful.
so let me see here. So
Yeah.
probably one of the first things I should do then in one of my, like I've got, if I look up, it's because I'm looking at a big TV screen. Those of you
Right.
know that one. Yeah, there are people who've been here. Okay,
Yes.
so what I think I should do, if I'm allowed to share, am I allowed to
Yeah,
share?
you should. I think I gave everybody permission to share, so you should be able to.
All right, let's see here. Where, okay. Yes, it looks like I have been. Okay, and I will do this. So
There we go.
and now I want to show meeting. Okay, so I can still see you. Give me 1 second while I turn
Okay,
the tiny little thing off here.
got it.
It's just an annoying sound maker. And let me know if I have my door open for the moment. So let me know if
Okay.
crickets or plane sounds or anything else gets too loud.
Yeah, got it.
He's pretty good at blocking that stuff off, but
Mhm.
not always. Okay, so this may take a second to load. I know this is not Tanya's favorite color. I'm sorry.
Yeah, she definitely has a favorite.
I can live with it.
She likes the 171, but it's
I
close.
do.
It's not yellow, it's bronze, but it's close.
Close enough.
So, so, so the reason I want to choose, for those who are interested, why did I not choose Tanya's favorite color? And I agree, Tanya, 171 is brilliant. It's brilliant for looking at all sorts of things, including coronal holes, but we'll talk about why later.
Mhm.
The one I chose here is actually much better at focusing on coronal holes, and that's a huge part of the story, right? And you guys,
Yeah.
because you're SMEs, you know why, because
Mhm.
it shows the dark, right? It shows the dark hole here that
Yep.
actually, to me, I don't know about anybody else, but to me, this looks like the fluke of a whale, right?
Yeah,
So see the
actually,
tail
yeah.
of a whale, and so the whale is diving to the South Pole right now.
Mhm.
So that's what it looks like. That's the body over there. And we have yet to see how far around this thing goes. But this coronal hole, you can look at it kind of like, trying to think, kind of like a chasm, almost like a chasm that falls off into the ground. Maybe the Grand Canyon or something like that for this perspective. Or you can even think of it maybe as water, but it's probably easier to think of it as like a chasm. And the reason why I say that is because when you have something coming on here, and if let's say this area is land, then if you fall off the chasm, you cannot, unless you're really good at jumping, this
Right.
kind of acts as a barrier to going any further. And
Mhm.
so if you have something doing something over here, it will only propagate. If you have a blast wave or anything, it's only going to propagate to here and then it's going to
Okay.
fall. So that's why I say you can also look at it as water, because something that propagates on the land will stop when it hits the water, right? And it
Mhm.
won't go to the other side. And so so think of these things as brick walls to a great
Okay.
degree when it comes to blast waves from these big eruptions. All right, so let's play this. Uh-oh, is it going to? It is playing. Yeah, I guess we're seeing it. Okay, I thought
Yeah.
it was playing way too slowly. There you go. So
Yeah,
you
it's
can
just
see
slow,
a
yeah.
little bit of a precursor here. You can
Mhm.
see where this stuff is, right?
Mhm.
And very soon, well, I guess a few hours from now, but you can see a bunch of like little precursors, and how you can see this thing is connected to lots of different regions. And we'll talk about those regions in a sec. I did take the time to make a couple, boom. I
Yeah,
did
there it
take
is.
the time to do a numbered, like a disc with the
Okay.
numbers on it. So I'll show that in a second. Let me just back this up just a little bit. So I'm going to swing this. This is something that we do typically in science. And sometimes you can even see swings
Mhm.
on stereo data. They'll say, gives you an option to swing something back and forth. And the reason why is because the blast isn't just about the blast, it's about what material evacuates, right?
Yeah.
And when you swing it, you get a really good chance of telling what is being evacuated out. Notice we get this stripe right here.
Yep.
This is telemetry outage. People say, oh, space weather doesn't do anything. Yeah,
Yeah.
it does. This telemetry outage, guaranteed, is because we were getting the big radio burst at that time up to about 12 gigahertz or higher,
Uh-huh.
and that blacked it out. So it was able to send down most of the information, but not all of it. And that's why we have this. Okay, we
Okay.
have a little bit of a strange kind of stripe with the exposure. Things are not set quite right.
Mhm.
But that's why you're seeing it there in that region. So just kind of ignore the stripe. But you can see the evacuation and even the blast wave. And I don't know, I should go check to see if Nariaki Nita has anyone checked to see if he's got his expansion coronal wave
I haven't
video?
had
I'm
a chance
on
to
it.
yet.
I'm on
Yeah.
it right now. I'll check.
Yeah, will you check?
Yeah.
Because if he does, we
Mhm.
should share that, because those are so brilliant.
They are. They really are.
Yeah, yeah. And he used to get those from Alan Tidal, if I recall. The Alan
Mhm.
Tidal helped create some of the algorithms, and then Nariaki has refined it to just a, to the point where it's just absolutely beautiful. But at any rate, you see a lot of evacuation, not just in here, right? Not just in here,
Mhm.
but you can actually see it up in here, right? And you
Yeah.
can even see it all along this boundary. If you watch this boundary, it doesn't change all that much, but you do see a lot of evacuation going up over it. You can see that blast wave. You can even see it almost looks like these were like trees sticking straight up,
Yeah.
straight out of the sun. Watch them kind of go like, if these are the trees sticking straight up, they go, and then they watch them. You can
Uh-huh.
watch them go when that blast hits. Boom. Do you see how they kind
Oh,
of
yeah.
push
Yep.
like this, and then they stand back up when that. But notice, whoops, if I get past that, notice nothing else propagates past here. You don't see
Mhm.
propagation continuing in here. Guaranteed, if this coronal hole were not here, that blast would have propagated to the west limb. I guarantee it.
Okay.
Possibly even
Wow.
to the south, to
Mhm.
the limb on the here in the southwest. Because it was definitely that strong. Yeah. But you notice that the whole west side of that coronal hole doesn't even look like it's been perturbed at all.
Yeah, that's pretty wild.
So that's what I mean by brick wall. Okay.
Hmm.
Thank goodness that this coronal hole was past center disk when this eruption happens, or we all would have
Yeah.
been crying in our soup.
Yes.
We would have seen this massive blast go off, and it would have hit that brick wall and stopped, and then we would have gotten nothing. And it would have been like,
Yeah. It's
right?
like, oh, so close again.
Close again. So luckily, the coronal hole, the god of coronal holes was doing the right thing and let us get some action here. Okay, so that's the first thing to notice. The second thing to notice, of course, is right here. This is back on the 18th, early on the like around 5 or 6
Hmm.
UT. Okay, notice you had some breaking of a loop up in here. Shows you that this region and this region, this is region 4345, this is region 4342, they are connected. And
Hmm.
up to this point, I kind of figured if anything's going to happen, it was going to be, there's going to be some synergy between those things. But it really surprised us. And I don't know if this eruption here was actually a full eruption or not. I never looked in the coronagraphs. I just know that it wasn't going to be Earth directed. So I didn't
Yeah.
bother. But when this thing, notice you do have a little bit of a dimming region building. But when this thing finally goes, you might notice, let me wait till I get to it really close, a loop right there,
Uh-huh. Yep.
right here. That loop breaks. Boop. See it? Boop.
Yep. It's real faint, but yeah, it's there.
Subtle, right? I'll show it
Yep.
to you in a different animation a little bit more brilliantly here in a sec. But that little loop, that was key right there. That loop actually comes out of the center region 4340, what is it? 4341, and connects, kind of loops all the way around this region. Oops, sorry for click to the view screen. I wish that thing would stop.
I know.
So it loops all the way out from the center of region 4341, goes all the way around and actually connected in here. Okay, and I'll
Okay.
show you that in a different animation. Here you can only looks like it connects these two, but it actually is further than that. But once that breaks, then all hell breaks loose.
Yep.
Okay. So that
Hmm.
loop was the key. All right. And part of it, the reason for it was because this was the corralling loop that actually held region 4341 and 4345 together. Pinched
Huh.
them. Okay.
Okay.
When we look super close, there are actually two filaments. There's a filament here that's connected to the bottom of 4341, and there's a filament connected to the top of 4345. Those filaments were parallel,
Hmm.
okay? And they were getting squished closer and closer and closer together. Finally, the magnetic tension between the two, not tension, pressure between the
Hmm.
two, so much, the stress between the two was so much that it broke this loop. This loop couldn't tether it all together anymore. And that's when it broke.
Hmm.
And that's when then it was able to separate. And as they separated, then everything let go. Now, when it let go, you see a filament here. And I know this needs to be bigger. I wish I could make this, can't make it too much bigger. Look how fuzzy that looks. I'll try to do a
Right. Yeah.
JHDR view here in a minute. But you had a filament here, you had a filament here. Those are the two parallel filaments. This whole section goes, okay, which is a filament that's kind of like in a backwards L shape right here. So you can actually see part of it up this way. And you'll actually see post-eruptive arcades that echo that. But look over here. See this guy? Don't forget about this guy. Because if I zoom out just a smidge so I can actually grab this bar here and make it roll. I think I can. Really close. So you can see as much of the top as possible.
Right.
Watch this thing. See?
Yeah.
See go, boom. That was part of it, guys. So this filament is part of that eruption. Okay. Notice the filament has another piece here. Get that. Click to view out. Stay away. Okay. This is kind of, I don't know if it's contiguous. I don't think it is, but this filament has kind of two pathways. So you can see part of it here and you can see part of it here. But this part, I think, got tied up in the eruption in the overlying arcades enough that this anchor let loose. That's my guess thus far. I haven't studied it in super depth. But when that, see how it lost it? That was losing it when this was already erupting. So we lost the first loop. This started going and it broke something in here, which then helped this guy release. Okay.
So it's like a big chain reaction.
Multi-step, massive reordering, massive reorganization, magnetic reorganization of that sun. So much so that you can see very dim, but you can actually see ribbons all the way here, all the way here, and even all the way up in here. Okay, let me wiggle that back and forth so you can see them. They're very dim. That's why I need a green screen.
Yeah.
If I wiggle just a teeny tiny bit.
Yeah.
See them brighten up?
Yep.
You see those ribbons brighten up? You can see them brighten up here. There's a little teeny tiny ribbon right here. All of this lights up in here. And this and this and this and this and all of this stuff. And even in here. Okay. So this is a massive reorganization outside of the main blow. This is a massive reorganization of plasma. You can even see the ripple effects of more stuff tearing off. And then, believe it or not, we're still not done. As this thing continues to kind of like the ripple effects of the whole blast wave and just the reorg and all that stuff. You always when you've got reorganizations that are this intense, you always kind of want to wait and just watch because more stuff guaranteed is being reorganized. Because what'll happen is it'll reorganize into a state that's lower energy, and then it'll go, you know, there's another lower state I can go to if I just reorganize like this. So it just gets like a slinky that just keeps stepping down the hill, right? Stepping down the stairs till it gets to the bottom. And then, so then what you see, remember that the set of filaments? You always pay attention to these little guys. Well, they're still erupting. Look.
Yes,
Oh,
they are.
yep.
So I don't, and that's as far as we got thus far. That's where we are. This one looks like it's been recaptured. That's my guess, is that this one did not release because you can even see the plasma going in here somewhere. So I wouldn't bet on that being an ICME, you know, a solar storm launch. But I'm not sure the region is done yet. I think this destabilized a good portion of this disk from the boundary of the coronal hole on. And so we may see some changing of this coronal hole boundary. Notice the arcades, right? You can see, let me get them tight in here. The post-eruptive arcades are kind of almost like a U, okay, for the main one right in here. And as I blast it out longer, you can see them erupting and going higher. So this was, especially as they rise up, the higher these arcades rise, pretty much the more energy you see. And you know, more energy the structure has. You can't take that verbatim, but it's a good kind of like, you know, rule of thumb. So as these things continue to burn, and look how long they're burning, this tells you that this has got some serious, you know, this has some serious energy. Now you also notice that may cause a sympathetic eruption up here soon, because I'm seeing little post-eruptive arcades. But down here, you also have arcades, and in here you have arcades. So not only do you have the main set of looping here, but you also have like 1, 2, 3, 4, maybe 4 or more baby structures that have lifted off with the big parent, which is here. I'll call that the mommy or the daddy. I'm cool either way.
Right.
Right? That could be the big daddy, and then the kids.
Big
Then
Daddy.
space, right?
Yeah.
They've launched with it. So to get a better feel for that, let me, if I don't mind if I stop sharing for a
Yeah, you're
second.
fine. No, that actually put it pretty much answered that initial question, like why, like in the chronograph, like part of it looked so dense to one side, and then you had these other things over here because there's multiple different things happening.
Yeah.
So, yeah, it
Now,
wasn't just one event; it's
it,
multiple.
it wasn't just one thing. Okay, so
Yeah.
now what I'm gonna do, and I don't know how well this is gonna come off, because
Okay.
we can go back to that in the different wavelengths in a second, because it'll be neat to look at like the global scale of this. But
Yes.
what I
Yeah.
want to show you first is something that I posted on Patreon that you guys might have
Mhm.
seen. Maybe old news for you, but probably not old news to the folks
Right.
watching. So, okay. Actually, let me make this big.
Uh-oh.
Only that.
Yeah.
Okay, can you see that?
Oh,
Mhm.
How's that look? Is that working for you?
Yep.
Can you see it? Okay, cool. All right, so what you're seeing, and yes, it's a bit messy, and that's why I showed you the simpler stuff first.
mhm. Yeah. Yes.
So here's a zoom in of region 4341. That's what I'm circling here, as you can see it
Uh-huh.
moving across the disk. And you can see region 4345. Okay, and the only reason why I didn't freeze it in time, this is a J Helio viewer movie. The only reason why I didn't freeze it in time is because I wanted you to be able to see the time range if you
Mhm.
want it. When you freeze those images, they never, the time freezes, and it's very irritating. They really should
Yeah.
not make it like that. All right, anyway, so you're looking at the magnetogram, okay? And maybe I could show you a different magnetogram first if you want to. Do you want to see the underlying magnetogram first before I show you all this overlying blooming stuff, or do you want me to just jump right into this?
I think you jump right into this
Okay.
since
Just
it's
want to make
up.
sure
Yeah.
it's not too confusing. Okay.
Yeah.
You guys know your audience better than I do. Okay,
Yeah.
so region 4341, I've got the magnetogram here sitting as colored. So red is one
Mhm.
polarity, blue is another polarity, right?
Yeah.
So go from red to yellow to green to blue and purple. So you can see very, very well that you've got region 4345, which is sitting in here. You can even see the little white specks here and the white color.
Mhm.
Those colors, those are the actual white light sunspots that I've got overlaid. The red is the magnetic, magnetogram view of it. And then what you're seeing in these overlying, ghosty looking images is actually overlying loops in, I believe, 193. So it was the same wavelength that we just finished looking at.
Okay.
I've got them ghosted so that we could see through them on purpose.
Yeah, makes sense.
Right. So notice, even before everything breaks, okay, before all this goes to hell in a handbasket, notice that this dark blue channel exists.
Hmm.
That dark blue, it's like almost subterranean. I don't want to say terranean, subsurface. So there's a big, probably flux rope structure, big magnetic structure sitting just underneath the water. It's like the submarines I was telling you about. When the sunspots
Yeah.
pop up, they become these periscope up. But
Mhm.
sometimes you can see all that surface underneath. Well, that's kind of what we're seeing here. So there's a big in this case, I think what blue is in, red is out. I forget which way is which, but you've got a polarity where the blue is the opposite of the two reds. So you've got
Got it.
one polarity, reverse polarity, and then the reverse again.
Hmm.
So that's a very complex configuration. If you had Scott McIntosh on, he would call it hemispheric band compression, which is exactly what we start seeing in the latter part of the declining phase.
Mm-hmm.
So that's where we're going, guys, is we're going to those more complex structures now because we're at that we're getting into the last gasp phase. This is
Okay.
why this thing grew so quickly and surprised us. I think it's probably surprised all of us. I don't think any of us expected this to be as dramatic out of nowhere like this. I mean, granted, this region was, had already lit off a few big ones, but I don't think anyone expected
Yeah, like a
X2
The next flare.
yeah.
with very little rise up to it. If you notice,
Mhm.
we were sitting around the seafloor for a long time in terms of X-ray flux, and then this just, within the last 24 hours really came up.
Mm-hmm.
All right, so what I have outlined here. So as you can see, if you were just to look at the magnetogram, you wouldn't see all that much magnetic complexity that made you go, why is this such a big deal? There
Yeah.
really isn't like a bunch of heavy delta spots or anything that seemed to charge this up. Really what it was the fact that we had this hemisphere, this band compression, this dark blue color in between these red colors. And if I took all this stuff off and you saw the other animation that I have posted, and I'll show it in my video in my forecast tomorrow,
Mhm.
but you'll see that channel, that blue channel, begin to narrow a little bit and elongate. And you can see it elongating a little bit because this
Yeah.
elongates. And this is a short time period, but if you look at it over a 48-hour time
Mhm.
period, you really see it elongate. And so it was squeezing and elongating along this ridge. And it was doing fine until earlier on the 18th, right about
Mhm.
1600. You start seeing that loop, and I wish I could freeze it, but this is a GIF
Right.
animation.
Yeah.
Freeze it, but you can see that loop, right? It's played a
Yeah.
1,000 times, so you can see that overlying loop. This is the one that I was telling you about. Remember the one that I said it could pop,
Mhm.
start the whole thing?
Mhm.
It literally comes out of the center of region 4341 and loops all the way around to back in here. So it completely corrals region 4345 and is overlying that whole region, including this set of filament channels right here that has both the filament, the lower filament for region 4341 and the upper filament for region 4345. So when that breaks, as you see right there, boom, everything else goes. And here are all these post-eruptive arcades coming out. You can see the main set of loops here. That's a post-eruptive arcade set. But look at this post-eruptive arcade set here, and look at this one building here. Okay, there's even a couple above, and then there's one that's off screen to the right. So this is what I mean by the daddy, right? That's the big boy. And then all this little junk. That little junk is all kind of hovering all around, and I have no idea how it's going to all transit as a group, as a
Right.
nice, happy CME family toward Earth.
Yeah. Yeah. Have we had a happy CME family like this lately? I don't know. I don't think we have.
Yeah, it's exactly. This is not something that happens all that often.
Yeah.
So, all right, any questions on this? Because I'll stop the share for the moment.
Yeah. I think no, that answered um a lot of the questions I had. I don't know. I think Christian's monitoring the chat, so I don't know if there's anything in there yet. But
Okay,
so we can probably keep
well,
moving on until I hear further.
sure.
All clear, just a bunch of amazed people.
Okay.
Okay.
Yeah.
So let me see, because then now we get into the part that I haven't had. That's essentially the extent of my the amount of work that I've been able to do at the
Yeah.
moment to even look at it. But what I think is a really good thing to look at, if you don't mind me sharing one more time,
Nope.
I'm going to go
Go
back to
for
our
it.
original share. So this view should be familiar to you,
Mm-hmm.
right? This
Mhm.
is the 193. But believe it or not, despite the fact that this is a really good view of filaments and coronal holes, another really good view for something like this, when you want to see how much material has been evacuated, is not so much 304, right? We all know 304. That's a good one too. And
Mm-hmm.
I'll just show it for a second, just so everybody can see it. This is SUVI, so it shows out really pretty well out into the mid corona already.
Mm-hmm.
You can even see the hint of the coronal hole in
Yep.
here, which tells you that's
Mhm.
how strong a coronal hole it is. If you can see a little hint of it out in 304, you're in good shape. It's gonna be some good fast solar wind. And we'll talk about
Yeah.
deflection here in a minute. Yeah, see these filaments here. This
Mm-hmm.
is the one I think that gets lost first, and then this one after. Let's see if it erupts. Yeah, you can see the dark filament here and the dark filament there. So there they
Up
go.
there.
That thing blows off. Yeah, see how it's gone? It's completely
Uh-huh.
gone. And then this one blows off later, but I think it gets sucked under. There's the one that's,
Oh yeah.
I
Yeah.
think it slingshots and gets stuck
Mhm.
back in there. Okay, so that's 304, and it's honestly not all that telling, but 284, which I think is something that a lot of people, because it looks so ratty.
It
A lot
does.
of
Yeah.
a lot of people go, why would you ever look at this? Well, this is a good one along with Solar Demon. And the reason why is because they've overexposed it on purpose. It's not that they don't know how to do photography. It's that
Mhm.
they don't care about the details on the disc. What they care about is the corona. They want to
Okay.
know how much of this corona has blasted off. Has anyone looked at this one? This is going to be my first time looking at this
No.
event in 284. It should be spectacular. That's my
Yeah,
guess.
I guess we're gonna find out.
We're about to find out, aren't we?
Yeah.
I'm gonna pull this down a little. Let's watch it in
Yeah.
real time. But I expect it to be
Yeah, like,
unbelievably beautiful. I know Corinna actually
Mhm.
looks at it, the space weather forecaster on M2M. She looks at this a lot to find stealth CMEs. And I
yeah,
think that's a pretty savvy way
Mm.
of looking for them because they're so wispy. Well, it wasn't as
Yeah.
spectacular as I expected. I expected more of the upper corona to be
Mhm.
blasted off, to be honest. But you do see, oh, that's interesting.
yeah.
I had not seen, had you guys seen this little bit here?
No.
I had not seen that either. See that little bit blast
Yep.
off? We gotta
Mhm.
find the origin of that. I'm not
Yeah.
sure. It looks like it might be limbs, so we'll look for that to
Yeah.
be on limb. But there you go. You can see,
Yeah, you can just see how it just moves.
yeah, and
pops
now
up.
and all this in the back. And now I'm wondering if this might have been a far-sighted eruption simultaneously.
Oh,
I'm
okay.
not sure if this source region, maybe it is. As you can see, I'm swinging once again, swinging
Mhm.
back and forth. But what I'm looking at the top of this corona here, what
Mhm.
all got evacuated, I'm trying to decide whether that's the same eruption.
I think stereo might be helpful as far as
Yeah.
whether or not there's something on the far side.
Yeah, too
Mhm.
far away though. This is exactly
Oh, yeah, that's
area.
right. Yeah, that's
Yeah,
right.
sadly, we're kind of blind here. I think it is the same eruption,
Mhm.
but it will be interesting to look at that in difference imaging.
Yeah.
Anyway, I expected a little bit more, like evacuation of material. That kind of surprises me that it really wasn't all that spectacular. But as you can see, you really can see well out into the corona.
Yeah.
I
Yeah.
mean, look at even all of this, the way all these arches bend like this. You can really see it. And so if there is ever a question of whether or not material is getting launched out, this
Mhm.
oftentimes will be the wavelength that gives you the best hint of direction of material, of
Okay.
all the overlying material, not just the thick, dense filament, but everything, all of the enveloping material too. Does that make
Okay.
sense?
Yeah,
Mhm.
it does.
Okay. So sadly, it wasn't all that exciting here.
That's okay.
Trying to think if there's any other, what else might be interesting. You've already looked at 171, so
Yeah.
I think that's probably it. But yeah, look at this. I mean, we had no warning. Usually you get more than just a tiny precursor. You get, over the
Yeah,
course of
there's always
days,
like a little
a
bit of a ramp
rise.
up.
Exactly, of the noise floor. And we really didn't get much of a rise in the noise floor at all before this thing hit. So yeah,
Pretty wild.
pretty wild.
Yeah,
Okay.
the other wavelength I tend to like is 211.
Yeah,
The,
well,
the
Mhm.
purple, the purple sun
I
or
like the
pink.
purple sun too, but
Yeah.
I don't have it on Subi. I'd have to go to
Yeah,
SDA to look
which
it
is
up.
fine.
Yeah.
But no, that's a good overview on that because yeah, it was interesting to look at and and then listening to people talk about it and like everybody has like, oh, this is gonna happen, this is gonna happen, and then so it's neat to like put it together.
Yeah, and I'm still putting it together.
Yeah.
So one of the things, of course, you have the C Corps on on SWPC's website.
Hmm.
One of the better sites to go to if they've got it up, please be up. I'm having a hard time loading it. Maybe it's not loading it because of
Uh-huh.
Zoom. Oh, there it goes.
Yeah.
Of course, is the C Corps directly from John Hopkins
Okay.
for the from NRL directly. Let's see if I can get it to play or load or something. Here we go. Oh yeah, okay. So I'll show that if you guys. So
Yeah.
that's
for
the one thing that, and they actually had their website down for a little while.
Okay.
And over the course of the holiday, they had it down, and
Mhm.
I kept watching to see if they'd pull it back up. And finally, I ended up pinging them. I don't think they knew it was down. And luckily, they're so great. Carl and Arnaud, they got it up as quickly. Arnaud spent an entire day. So Carl Bounce, if you know him, he's known
Yeah.
as Sungrazer Comet Guy. Yeah.
Okay. Yep.
This is part of his his bailiwick and his care. This is one of his things that he takes care of. I don't
I
know if he's
love
the
it.
PI on this instrument or
Mhm.
if he's just, taking care of the coronagraph, as a working PI or working on the website or what. But they both were very responsive. And the reason why I like this better than the one on the Space Weather Prediction Center page
Mhm.
is because look how clean these images
I
are.
was gonna say it's like
Oh, wow.
it looks really
Yeah.
like high definition.
Yep. Their background subtraction is beyond end
Yeah.
all be all. And that's not the only cool thing, because if I did this on purpose,
Got it.
sliding down,
Yeah.
we get the
Yeah.
difference image. And
Uh-huh.
the difference image, I don't know why Swipsy doesn't use a difference image. Look at that
Yeah.
beautiful blast. Isn't that gorgeous?
Uh-huh.
Oh,
Watch it. Watch it.
Yeah. Yep.
Yeah. Ready?
You
Where are
ready, ready, ready.
Wait for it. Boom.
Yeah.
Right? Yes, gorgeous.
Yeah.
And the fact that they've
Yeah.
done this with Earthshine
Uh-huh.
and Moonshine as bad as it is, Earth glow and moon glow, whatever you want to call
oh,
it,
wow.
is just spectacular that they've done this.
Yeah, that's something right there.
Yeah, so full halo, not
Uh-huh.
just stuff being blasted on this side, but
Mhm.
stuff on this side too. Very strong shock. So expect that radiation storm to stay with us. It looks like it's already, is it up at the S2 level already?
A little, yeah,
S1.
S1.
S1
Okay.
still?
Because I got an alert saying that it was there, but then it didn't, I haven't checked it on it since. So
Okay,
yeah.
well, I would not be surprised if
Mhm.
it continues to rise and reach an S2 level, especially as this structure reaches over us, because it's that ESP, right? You guys
Yep.
remember energetic storm particles.
Mm-hmm.
So, and this is because it's coming, the shock, as you can see, full halo. This is all, this is definitely the
Yeah.
apex of the shock coming at us. So we're going to get the full force of it. So it's gonna give us a strong ESP. So I wouldn't be surprised at all if we hit S2 levels. Even if it starts declining,
Mhm.
when the shock gets close, it'll rise again. So,
Mm.
I'm on the 20th. If you guys hopefully nobody has to fly.
Nope. I'm still here for a little bit.
Are you?
Yeah.
Good. Good. So, all right, let me stop sharing. So I've
Okay.
hogged the screen long enough. That's
No,
okay.
you're good. That was super helpful. So,
Good.
because I know, I actually had a couple messages before, coming on here today, and it was like, are you guys going to talk about what happened? I'm like, well, probably.
Yeah. Why would we want to talk about that?
I know.
It's
Yes.
God, X flares. That was so yesterday. That was so
Yes.
Stellar Max.
That's the thing that gets me. It's like everybody's all like bummed, like so like, oh, we're past the max. I'm like, hold on. Like this isn't the end.
This isn't the end yet. It's one of the
No.
Yep.
typically the largest events of the solar cycle occur
Yeah.
here at last gasps. Yeah.
And it's kind of like what you're saying, like you're getting these things that's like sandwiched together, these all opposite polarities. So it's like then you get these surprise events that
Right.
come from that.
Right.
So
The news cycle's going,
Mhm.
come on, I want to start. And it's trying to push
Yeah.
those bands down. Those bands are like pushing back
Like,
on, no.
no. Yeah.
So it starts getting really compact in there. And when they pop up to the surface, they pop up like a zebra.
Yeah.
Stripes. Like, oh my goodness.
It's like, oh boy.
You see, yeah, positive, negative, positive, negative. It's like, oh my goodness, this is like a layer cake, a magnetic layer cake. And that always spells trouble when it
Yeah.
comes
Mm.
to big energetic.
Definitely.
Yeah.
So I guess with that, now that we've finished the not really forecasting portion of the of the evening, okay, we can go into some questions that we've prepared for you.
Okay, we'll see
You
how
ready?
well we do. Now, sadly, I did not have I know the mandatory question, so I wanted to, prior to this
Yeah.
occurring, I wanted to actually pull up some of the imagery, but
Uh-huh.
I didn't have time, so I'll just have to
It's
talk
fine.
about this,
Yeah.
do hand waving. Besides,
Yeah.
I've shared the screen enough tonight now. Oh,
Yeah, so it's okay. So the first one is like it's kind of, easy, I guess. Like how did you get into the space weather field?
oh my goodness. Space weather field, or I mean, it's funny. it's one of those things where you keep doing what it looks like you're supposed to be doing, and then it got crazier and crazier and crazier, and I just went, okay, this is obviously the direction the world wants me to take. But I got into science, into hardcore physics and science, because I was a big sci-fi buff when I was a kid.
Okay.
I've read, lots of different authors. I can, of course, quote a few if you want, but I think the one that's the most apropos right now because of the AI, the whole AI thing.
Yeah.
Is
Yep.
Isaac Asimov, right?
Mhm.
His Foundation series, his iRobots, all of that, all of this, the novels that he wrote were very prescient, and it's kind of creepy how much and it's not just creepy, it's actually, I shouldn't say that because we're going to talk about astrosociology later, and it actually really folds well into that.
Yeah.
Very, not just prescient, but people go, oh my gosh, he really predicted what they were going to look like. And it's like, because the AI robots, if you look at them, they look exactly like the ones that he envisioned. But it's like, are you sure that it's not AI, that he envisioned them and read the future, but rather people who are making the robots built them the way he described?
Right. Yeah.
So it's more, I think it's more along those lines, and that shows you kind of a hint of what astrosociology is, right?
Yeah.
How incredibly impactful it is that why does the future actually look like what was written about in the past? Because the past inspired it, right? It
Yeah.
made a
Yeah.
much bigger impact than people oftentimes realize. So I was a big sci-fi buff, and when I ended up having to take physics classes, I realized that the truth when it came to physics was unbelievably complex and just wild. Like what got me was things like Lagrangians, and I'm not going to go into the details of it, but when you have a system, a very complex system of motion, and it's really crazily complex, and how do you describe it? And it's unbelievably hard to describe, but then all you have to do is just pivot into and transform into a coordinate system, into a frame of reference where everything gets still. And then suddenly, if you transform into that proper coordinate system, what was unbelievably complicated and impossible to understand becomes unbelievably simple and poetic and beautiful. And I thought, whoa, if you can just change how you look at something by just reframing how you're moving around something, right? Like here we on Earth, we don't recognize that we're on a rotating thing. We think we're in an inertial frame. So we see Coriolis forces. We see the toilet water swishing around in circles and spirals and going, why is it spiraling down? But if you were in a total inertial reference frame and you could watch the toilet, you'd see the water actually went straight down.
Right.
From an inertial reference frame, that the path of the water is not spiraling. It's actually going straight toward the center of the Earth. But because of the Coriolis force, because of the fact that we're standing on the edge of the Earth on a rotating thing, it makes it look like it's swirling. And it's a neat kind of concept. Now, granted, you have to affect, there's more forces than that. It's more complicated than that. But it's a neat kind of idea that if you were to step outside of a moving frame, if you want to see something differently, or if you step inside a moving frame and change how you're looking at something, then all the motion, all the physics, all the things that you observe look radically different. And I thought, whoa, you mean there are coordinate systems that don't stand still but move and arc and bend, and you can bend right along with it, and suddenly a ball that's moving in all sorts of weird ways will be completely hovering still in the air. If you were in the right coordinate system, that ball could just sit still. And I thought, that is the coolest sci-fi thing I've ever thought of in my life.
Yeah, that is pretty cool.
I was like, how, just by changing your frame of reference, you can make magic happen. And I thought, okay, I've never read a sci-fi book that's that crazy and cool. And because not only could you do it with space, but you could do that with time as well. And I went, whoop.
Yeah, like what?
And so I was like, so you can transform coordinate systems not only spatially but temporally, and then something that you could make the impossible possible. And I said, okay, So I had my my sci-fi novels open, and I did that, and I was reading that in the physics books, and I went, I'm going to put this book down and I'm going to pick up a textbook. And so that's what I did. Is that I decided to become a physicist because literally the truth was stranger than fiction. No sci-fi novelist could write some of the stuff that actually was, that mathematics itself was right. We had already written many times over. So that's what got me into it. And then as I, everybody loves space. Most people, if you're into math and stuff and space and sci-fi, you're going to be into things that have to do with space. And when I got into at UCLA and I was looking to get to do some like a senior thesis, I ended up running into a professor. I looked online, for professors that were taking in undergrads to do senior theses with. And one of them was Chris Russell, Dr. Chris Russell from the Earth and Space Sciences Department in IGPP. And he was a space physicist. And I'm like, space and physics. That sounds good, right? Because they're two things I love. So I went up to him and I worked for him and for free at first. And within a few months, he said, "Hey, do you want a paid gig?" And I went, "Are you kidding me?"
Like, no.
To research? Sure. So as an undergraduate, I actually got paid to research. And so I stuck with him for several years, ended up publishing a couple papers actually as an undergrad, working, well, at least my work was. And I don't think I was lead author at that time, but did work on Mars, believe it or not, the Mars magnetic field. And then when it came to me graduating, I was looking at graduate schools. And yeah, I was going to go into, probably into space or something like that. And I was searching graduate schools, and Chris said, "Please don't leave." He says, "I've taken 3 years to train you. Please don't leave. Just be my graduate student." And I went, I thought about it and I was like, well, I've been at UCLA for a long time, but I said, okay, only if I get her job. And I was pointing at a girl named Gretchen Lindsay. And Gretchen studied the sun. She studied transient structures coming off of the sun. And she was graduating. And he said, "Done." He said, "Done." So I became this, I picked up her work where she left off and studied literally from the edge of the sun out to, the edge of the earth, and studied the geoeffectiveness and the solar origin of coronal mass ejections and why they were oriented the way they were and whether or not we could predict some of that. And I wrote some papers that I teach to this day at some of the concepts I teach in SWIN. So that's how I got there. And then how I got to become Space Weather Woman was because to get through grad school, I had to create a studio that I could do audio. I was also a musician. And I did albums and records for people and webcasting and all sorts of stuff, which I won't get into the details of. But just suffice to say that I was an artist and still am. And that was the only way I could stay sane, was to do this stuff while getting my doing my grad work. Matter of fact, my band actually took off at the time, and I actually had to tell Chris that I was thinking of quitting. And he just said, "Please don't quit." He says, "Just slow down. You can take extra time, but don't leave. Please just stay." So I did and got through it. But shortly thereafter, everybody was saying, shortly after I graduated, everybody was saying, "Well, we need people on the Weather Channel and we need all of this stuff." And because I had met my husband who was in video, he got me to get into video. I had already had the audio, I had the studio, all I needed was a green screen. And I went, I think the universe is trying to tell me something.
Yeah.
So it was just this nexus at one point. And that was, I don't know, around probably 2014, 2015.
Okay.
And that's when I started doing it. I was really clunky at first, but over the course of time, things got bigger and bigger. I mean, there's more to the story, but I don't want to, we've already been on for so long. I don't want to.
Yeah. It's really fun though. Because I know when I found out that you did music, I was like, no way. I was like, that's pretty cool.
That's actually why I got on Twitter. I first got on Twitter in around 2013 or so, when the sun was beginning to really act up. And I saw people on Twitter, I was there for music, but I'd see people talk about the sun sometimes, and they were like really paranoid and panicky. And I would just tell them, "No, don't worry about it. This is normal," that kind of thing. And the more I would answer those questions and just send people on their way, the more questions I'd get back. And the more questions I get back, the more intelligent the questions would be. And then, and I'm still trying to do my music thing. And I started noticing people on social media, you know, on Twitter in particular, who, if they were Aurora folk, I would know by the questions they'd ask. And if
Yeah.
they were amateur radio
Mm.
operators, I'd know by the questions they'd ask. And I started noticing these distinct groups, these very distinct groups that would ask very specific questions about different space weather phenomena. And it was really cool because in the end, that's what caused me to really kind of put it all down and say, okay, I'm not going to do music anymore. I guess I'm here for space weather.
Mhm.
And that is also one of the parts of this nexus of all these things coming to a center. And I'm sitting in the center going, I guess this is what the universe wants me to do.
This is
Yeah,
what
so
I'm
it's
doing.
part of it. Yeah,
Oh, that's
great.
pretty cool though.
Yeah.
So I guess the next one is what, because I know you have you seen Aurora or no?
My Aurora story is both extraordinary and
Yes.
pathetic
Yes. So do tell.
simultaneously.
Yeah.
So the pathetic part is I've only seen Aurora once,
Mhm.
and I never was outside. I saw it through a window.
Okay.
So that's the pathetic part. And how can that be extraordinary? Well, it's extraordinary because the only time I've ever seen Aurora was during the Gannon storm. So that was
Oh,
right.
yep.
And I wasn't on the ground.
Okay.
It was essentially May 12th of 2024. And I had to fly, or got to fly rather, to Italy,
Mhm.
Los Angeles,
Mm.
because I was teaching that space weather fundamentals course in I can't believe I'm blanking out on the name right now. The city, Lockwood. Thank you. I'm like
Yeah.
thinking, switch. Come on. So in Lockwood. So, which by the way, I think we're going to have another one. I've got to talk to I owe Domenico an email.
Yeah.
So we might have another one of these, maybe in 2027. We'll see how it works out. But at any rate, so I got on a plane essentially late evening. No, not late evening, my fault. Before sunset on the 12th, on the 11th or the 12th. I can't remember which day now. But I got on a flight. It was like 4 p.m. The sun hadn't quite gone down, but I knew, and we were still at G2-ish levels. So I knew there was a very good chance that I'd be seeing Aurora, because Aurora had been, blazing, and it was going to take
Right.
a long time. Even as the storm was calming down, it was going to
Yeah.
take a long time for it to wane. So I got in a plane, and the flight was literally from before sunset until, I flew all the way over on the night side.
Mhm.
And when we landed, it was going to be 8 or 9 in the morning. So I basically got to fly the entire night side. Okay. So what was cool, I made sure that I got a window seat,
Yep.
always,
Have to.
make sure I had a window seat on the north side of the plane, right? So I'm looking north.
Yeah.
I'm smart about that. And even before the sun went down, right, I've got my sweater, and I made a little
Yeah, like
tent,
Mhm.
looking out the window, because I just knew that I probably was going to be able to see Aurora before the glow was gone, right? And
Yeah.
sure enough, I started seeing a faint little glow. The sun had gone down, but it was still dusk, and the whole sky was still light blue. And I'm like, I think I see a little bit of Aurora. So I kept watching, and sure enough, it got brighter and brighter and brighter. And it came up as like this dim, kind of misty stuff,
Mhm.
right? Just on the nose in the direction, the eastward side.
Mm.
So as things went, as it got darker, the Aurora got brighter. And as it got brighter, it also became this beautiful streamer. Very, very well, very good, discreet looking thing, very well formed, very beautiful. And then it would get more wiggly, right? And then it would start getting even more wiggly and began to branch off just a little bit. And I said, and this is over the course of 5 hours I'm
Right.
watching. Okay. I mean, I literally did not take my eyes off the plane pretty much the entire night. And I'm taking pictures, I'm even videoing. But what was really cool was as I'm flying through this over the course of hours, not only am I seeing, these discrete arc, this essentially main discrete arc, and watching it break and pseudo breakups and stuff like this, and then it come back together and all that kind of stuff. But I could literally tell when I was reaching midnight, because everything started changing.
Yeah.
So then the arcs really started breaking up, and then suddenly I had 4 arcs, 4 different auroral streamer like arcs that parallel, kind of pseudo parallel to each other. And I started seeing all these puff, 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 all these puffs. And I'm like, holy crap, I don't even have to know. I am post midnight, pre dawn.
Yeah.
So I knew when I went from post dusk, post sunset, right into pre midnight,
hmm
flying through that sector. And I literally saw the change from pre midnight sector to post midnight sector. And then as I flew closer in, I saw a lot of the breakup. Man, now the Aurora was scraggly and along a ton of different lines. It was just branching like crazy, a lot more diffuse looking, not nearly as nice and discreet looking, but just much more active. And then on the inside, I saw all these pulsating patches.
Mm.
And the closer I got to the dawn, as we got
Yeah.
more closer to pre-dawn instead of post-midnight, moving into the pre-dawn sector, I started seeing, the pulsating got bigger and bigger, and it got even more spread out.
Yeah.
And it was just, I can't even tell you how amazing it was, because as I continued going out, as the sun, I started watching the sun rise just a little bit. I saw the lightning of the day in the east, and I'm watching the aurora fade. And as it gets brighter and brighter and brighter, the aurora is fading more and more and more. It's still going,
Yeah.
right? It's fading more and more and more. And the last little things that I saw were the pulsations. And the reason why is probably because of the movement, right?
Yeah.
We move so much more. And I can't tell you what an honor it was, because I know a lot of people seen aurora, all different types of aurora. Like, oh yeah, I've seen that. But it's over the course of what, 10 storms, 100 storms, depending upon, it's all, you've seen a particular kind of aurora, at least most people have seen a particular kind of aurora, a specific kind of aurora from one storm. And then they've
Yeah.
seen a different kind of aurora from a different storm and a different storm. I
Mhm.
literally got a tour from dusk all the way to dawn for one complete storm, just one. So I got to see that whole dusk to dawn spatial, evolution of the structure. And it was just, for it to be the Gannon storm, I mean,
Yeah.
what can I say? I mean, there isn't a bigger gift to me than getting that.
That's awesome, because it's like, yeah, not many people can say they could witness that like in the real time where you get the whole tour. That's pretty cool.
The whole night sector, from
Yeah.
literally from pre, from
Mhm.
set
Yep.
to
All the way to
sunrise.
dawn.
Mhm.
Yeah. That's
And
the crazy part about air travel. Like,
yeah,
we
yeah,
talk about how airplane travel is kind of like, people equate it to like like on a bus now these days. But to me, it's still always like fascinating to me. And the fact that we do this and it's become so commonplace.
so
But
routine.
yeah, but yet it's amazing to, you're just flying across the sky and then you can see all this happen.
Yeah, of course, there are two funny stories or two
Yeah.
funny things to think about regarding that. The first little thing was, sadly, it was also during an S2 radiation storm.
Yeah.
Oh, yes.
Yeah. So there's that. Uh-oh. I think I lost her
Oh
video.
no.
No, we lost her video. We'll see if she comes back. Wah, wah. That darn internet. I can still see you, right?
Yeah.
Okay, I'm just making sure because I'm trying to figure out if it's which internet connection it is.
I think Tamitha is trying
Okay.
to work
Yeah,
on
that's
this.
fine. Okay. Because a lot of times it's my internet connection, so so it's all good. No, that actually that's a really good story. I haven't heard that one from her yet. So like it would be cool to witness it, the
Mhm.
whole that whole um, you know, not morphology, but like I can't think of the words right now. It's been a long day. But I think,
Show
I think
how it
yeah,
changes from
yes.
dusk all the way to
Yeah, all the
dawn
way to
side
yeah.
with all the rolled forms, but seeing it from
Yeah.
above the ground, because we got to see the storm on the ground. We
Yeah.
saw it for Friday night into Saturday morning, and it was
Mhm.
pretty much Aurora all night. But again, it was going all the way through, and we were looking south. But I think
Yeah.
on May 12th, it was not as the Aurora oval wasn't as stretched and thick, so
Yeah.
kind of easier, almost easier to grasp it. So, but yeah, that's a beautiful story.
It is a beautiful story.
Yeah, and the radiation storm got me, right? I was talking about radiation
I
storms.
know.
My
And then it
phone.
was like, poop, gone.
I don't know what happened with my phone. I'm using a phone and it decided, oh, you want to update? And I'm like, no,
No, I don't.
I don't. I'm in the middle of something, actually. So, but I heard the whole thing. So I never
Okay,
was
good. Yeah.
offline. I was just, my camera just went weird.
Yeah.
Yeah, well, so the other really funny story, outside of me glowing in the dark after dealing with going through an S2 radiation storm, I don't advise it, but I didn't really have a choice. But
Right.
the other thing that was really funny, because and this is the human aspect of us, some people know I'm a swimmer. I was a competition swimmer for a long time, and being in California, of course, I've swam in the ocean a lot,
Mm-hmm.
right?
Mm.
Well, when you're in the ocean, of course, your head sits the water just barely above the water, right?
Yeah.
So, so when you're flying, right, the Aurora doesn't look above you; it looks almost equal
Uh-huh.
with
Oh.
you. So,
Yeah.
you're not really looking above too much. You're looking at it very much from the side, and you don't get. I mean, at least I've not been in a flight. Obviously, in this particular flight, it was not in a flight where you had anything that resembled coronas. It was definitely,
Yeah.
felt like it was at eye level. And the funny thing is that during one particular expansion phase, right? So you guys will appreciate this.
Mm-hmm.
So the auroral oval is literally going like this, coming at
Yeah, like you're like, whoa.
and because and so I'm watching it coming at me, and because I'm so used to, and I just I'm not even thinking about it at the time, but I'm so used to being a swimmer with the ocean, right?
Yeah.
And you see, I can't tell you how many times I've seen either waves coming or whitewater. So the wave is crashed and the whitewater is coming at you. And what you typically do, because it's Pacific ocean waves are pretty intense, right? They can be, and so you have to dive under the water, right, to go underneath the wave so that it rolls over you, so you don't get somersaulted and everything else. So just instinctively, as I saw this big wall of stuff coming at me, the first thing I started pulling back, and I went, duck. I said to myself, duck under the water, duck, because it literally looked like a wall of. And I just went, what am I doing? This is silly. So that's my hilarious, fear of Aurora.
My fear.
Flashbacks
Yeah.
of being trounced by whitewater.
That
Anyway.
really is a great story though. So I'm glad I asked it.
Honestly.
Yeah. So I guess now we'll switch topics a bit, but so how did space weather communication field evolve over the years since you've been doing this? And what do you see as success stories and what are challenges?
Oh my goodness, I don't know.
Yeah.
How has it changed over the years?
Yeah.
Well, I mean, I'm going to date myself because, I'm of the generation where I was in this field before it was called space weather.
Okay.
We didn't
Yeah.
have a name. The
Okay.
space weather was just called space physics. And then someone came up with the name space weather, and basically all the scientists went, ew.
Of course.
No,
Yeah.
no, we are not going to do this. We are not meteorology. And I think Lika or someone LWS or someone who's in PR said, no, I think space weather is going to stick. And sure enough, it did. So now everybody's kind of just, all right, begrudgingly said space weather. But what they say is, operational space weather, right? So that
Yeah.
the academic field can still do its space physics and aeronomy. It's still called SPA in GU, space physics and aeronomy. But in the operational field, right, we call it just space weather.
Okay.
So there's, that I think is part of where the shift is.
Mm-hmm.
The academic community and the operational community used to be very, very separate. And we're beginning to see a little bit more of a connection.
Yeah.
Which is nice. But it's still very slow. I think we're going to still, I think it's probably going to be another decade or so for the before we get a lot of like hardcore scientists switching over and making part of their conference going or their workshop going schedule include operational style
Okay.
conferences. But those conferences are growing.
Yeah.
So that's a positive thing. What may actually dovetail faster though is terrestrial meteorology with space weather, which is really
Yeah.
what the program's all about, right?
Yep.
We're kind of, because that's when I started doing the SWIN thing, that's what I recognized was that it was going to take a long time for academia to want to pivot in the direction of operations, simply because I think they may look at it as a different field. Let me just be very diplomatic and say they look at it more as engineering than science. So for them, it's like, I'm not really interested. Whereas meteorology, they kind of look at it, they're like, oh, that's just part of my job. And if I include space, well then, wow, that's a step up for me.
Yeah.
So I think that's probably why it's dovetailing faster. Those fields are dovetailing faster. Terrestrial meteorology and space weather, operational space weather, are dovetailing faster than even academia, space physics and operational space weather. It's you wouldn't think that. It seems counterintuitive, but I think that's the case.
Yeah.
And where has it changed the most? Well, it's honestly been this cycle. I was seeing a little bit of it last cycle, but it's been this cycle. And the key word is accountability.
Okay.
We, the public and the citizen scientists and all of you have helped literally to kind of hold not just SWPC's feet to the fire, but any forecaster's feet to the fire. And when you do that and say you need to make sure your forecasts are right, that challenge is something that luckily scientists take seriously.
Yeah.
So it's good to see this pivot, because I think that's part of what's attracting more scientists to this arena, is that it's not just a matter of putting out a forecast and who cares if it's right or wrong, as long as you can check the box and say a forecast exists. Now people are relying on this more and more and more.
Right. Yeah.
And that's the key. And I think as long as we keep pushing in that direction, we're going to get more and more progress. So hold your feet to the fire.
Yes. We all know Tanya likes to bother the SWPC people.
Good. Good.
Sorry, I just had to call her out on that because it's funny.
And then the other thing too, hold the terrestrial meteorologists who dare to dabble in this field without the right skill set, hold their feet to the fire too. Because, just as they get things wrong, just as SWPC will get things wrong, they will get things wrong. And if you're doing such, you can get both of them to kind of come together.
Yeah, it's like, come on.
I mean, this is where the errors can really propagate. So you get two forecasts that carry fair amount of uncertainty, and you have a cloud forecast, you have it's not even KP forecast, it's more geomagnetic watch that's out, but it's treated as aurora forecast. So you have meteorologists that are putting out maps for auroral visibility and for cloud forecast together. So they look really cool. Those maps are really cool looking, but they have no useful data whatsoever.
No.
Right.
And that, and that's what's so frustrating about that is what ends up happening is that we get people that are, maybe first timers, right? And they're going to go out and look for Aurora, because obviously Aurora is somewhat like a gateway drug to this field.
It is.
If I may so graciously say so.
Yep.
And because of that, right? Well, and because of that, first timers will, if it's the first time experience, if they have a good experience, they'll do it again. If they have a bad experience, well, they'll never do it again. And they'll tell all their friends, oh, don't try that. That drug's dangerous.
Yes. Yeah. You don't want any.
Leave it alone. You don't want to touch that. Or, well, it did nothing for me, kind of thing.
Yeah.
So bad forecasts really do injure us as a field. And it's not even so much the bad forecasts themselves. I don't think we should blame the tool. I think we need to honestly blame the communication that the forecasts, that space weather forecasts, aren't at the fidelity level that we expect because of the complacency we've gotten with terrestrial forecasts.
Yeah.
We say, well, it's weather. How come space weather isn't as right spot on as terrestrial weather? It's weather. And because of that lack of communication, right, that people get this expectation that, well, they say there's aurora, there's going to be aurora.
Right.
And when it's not, they get let down and really PO'd, especially if they decided to propose under it. And it turns out to be the worst night of their life.
Yeah, it's like, oh no.
I think the universe is telling me I shouldn't get married to you, Richard. No. Yeah, it's like, no, we don't want that. No,
Yeah.
no.
It's like, whoops, my bad.
Yeah. No, Richard was just a name that came out of a hat. It's not associated with anyone. Don't be looking for Richards in the vicinity.
That's too funny. So I guess we'll go into, what is your favorite space weather story? Do you have one?
Do I have a favorite space weather story?
Yeah.
Story about what?
I like does any event or anything like that stick out to you the most? Like I know the Gannon storm was a good one, but I know you also were doing a lot of work with Solar Cycle 23, which was a pretty active, so like is there like any sort of like thing from anything that stands out for you, I guess?
Oh, and okay, because when you say stand out, my mind can go a thousand different directions. So like stand out funny, stand out scary, stand out, just
Ooh.
memorable.
Yeah, maybe just memorable.
Memorable.
Yeah.
To be honest, the most memorable events are ones I don't remember.
Oh, okay.
And I know it's kind of a wacky thing to say, isn't it? But, because I wasn't either studying space weather directly at the time because I was too young, or I wasn't born.
Okay.
And that has a lot. I mean, that says a lot, because I've been in this field for, oh my gosh, I don't even want to tell you how long, but I was a grad student in 1990. When did I become a grad student? 1996. So, that's a long time. And I was studying space weather even prior to that, because I was working with Chris as an undergrad.
Yeah.
So when you can't, when the most memorable events have occurred prior to me even having a career in space weather, that tells you the time scale of our sun is so incredibly long that careers can go by and people won't know what the sun can do. Luckily for me, part of my career, my studies, have been to study historical cycles.
Okay.
So it's not just about, because when I came and cut my teeth on space weather, it was cycle 22.
Okay.
And then I studied, it was cycle 22. And then cycle 23 was kind of when I left for a little while and went and did some dabbling in engineering, noticed the cycle, but wasn't on top of it day by day. And by cycle 24, I was back on top of things. And then at Solar Max cycle 24 was when I ended up doing space weather for, as what I do now. And so forecasting all the time. And I'd never been forecasting all the time when I was more of an academic. So, I know a lot about cycle 24 and up. But the interesting thing was that studying clear back to cycle 19, cycle 18, cycle 17, right? I was studying cycles and aware of cycles back from the 1940s and 50s.
Okay.
And I've got several interesting stories, but one of the most interesting aspects of having that kind of knowledge, of, having 10 cycles of knowledge under my belt to a great degree, is that we haven't seen anything that the sun can do. And I don't mean anything like micronova, I don't mean that. I mean just pain in the arse. You're ruining my day. You're ruining my life. Will you just shut up already? Kind of cycle. Because we've had, back in the 1950s, and this is like cycle, I should pull up my data here, but it's like cycle 17, cycle 18, somewhere in there. I think it started with 16, but 16, 17, 18, and then 19, of course, was a peak for big storms. But cycle 15, 16, 17, 18, those cycles were incredibly strong for radio bursts. Unbelievably. Some of it is, in fact, I think one of the strongest, if not the strongest event that we've ever seen recorded in the modern era was back in the 50s and 60s.
Okay.
And if you look back at the old Mount Wilson sunspot record, you will see sunspots that are like, take the sunspot we got now, 4341.
Yeah.
Make that 5 times bigger.
That's pretty big.
And now make that dang pest circle around the sun 4 times before it finally disappears.
Huh. Yeah. And you
That's how,
yeah,
and so
pretty wild.
when you get sunspots that are that large, not only can you get, of course, big eruptions, but you get massive screams from the sun, massive radio bursts. And I don't think that we have any clue in the modern age how much the sun can disrupt our communications and for how long.
Yeah.
And yet we knew it back in the day when we had, when our radio communications was just essentially HF, maybe a little VHF. People used to have, there are still people that I talk to who are amateur radio operators that still remember the days when just regular antenna, UHF antenna TV, VHF and UHF antenna TV would go out because of the sun. So it wasn't like direct TV, satellite TV. It was your normal television set all over the planet that would go out on the day side because the sun was screaming these really, really intense solar flare, these radio bursts from the solar flares. And we've not seen, I mean, we have no memory of that. So with some of these constellations, these LEO constellations now, of satellites that literally move, have to make 1,000 or so maneuvers in a week or something. It's outrageous how many maneuvers these LEO constellations have to do. These satellites in these constellations have to do to avoid collisions with debris and whatever else is out there. It's really, it's almost mind-boggling. If we can't communicate continually with these satellites, if we end up getting a cycle where the sun is chirping like a songbird, and we have these disruptions in communication frequently, there's a good chance that they're not going to be able to make a call, or a satellite isn't going to receive a call to tell it to move and command it somewhere in time before it crashes into something. And I don't think we have, we talk about space traffic and what I lovingly call orbital Tetris, right?
Yeah.
I can't remember if I dubbed that or got that from someone, but I think that's a neat way of thinking about it, because that's how busy our space is getting up there in low Earth orbit. But if we can't do traffic management up there and have constant communication with these satellites, there is going to be a solar cycle where we're going to go, oh my gosh, this is untenable.
Yeah.
And it's going to be too late. By the time we realize it, it's going to be way too late, because we were going to be so reliant on being able to communicate all the time that, if you're on the day side and your whole day side is blacked out, you can't relay stuff to the night side to have it pick up the slack. It's going to bite us in the butt, but we just have no memory of it. So that's one of the things, was some of these really, really big events. And of course, the Carrington event, the one that really gets me is the 1967 event, to be honest. Once again, because of a radio burst, not so much because of solar storm, but the fact that if we didn't have SWIPSI at that time, which it wasn't called SWIPSI, it was a different name, that we would have been in World War III.
Oh, wow. Okay.
Well, because it was in 1967 we got a massive radio burst from the sun, and we literally thought it was the Russians jamming.
Because that was
structure.
That was definitely Cold War stuff. Yeah. So
Maybe.
that's pretty scary.
And we were inches away from it happening. And luckily we have, SWIPSI is really close to NORAD, right? All there in the Cheyenne Mountain, underground. And the generals, there are still a few old timers that are alive who were.
Uh-oh. Oh. Hang tight. Darn darn phones. We'll give her a moment here. But to say like, you know, she has a good point. Yeah, we were
There
just
we go.
yeah, we are just saying it's like you have a really good point about this. Like you know, there's a lot of stuff that has happened and and humans have this weird way of like kind of just forgetting about past, even if it's not that far long ago, and just assuming all this stuff's gonna work forever.
Mhm. I do. And
Yeah.
and when people think about it, and this is kind of why I wanted to focus on radio bursts, for example,
Yeah.
because everybody thinks, they always think of it, space weather, the same way. It's going to be a big geomagnetic storm. It's going to be
Yeah.
some micronova, some kill shot, you know? And it's like, I don't know if that's the way it's going to really
No.
affect us. I think there's a lot to be said for the, you know, the overlook, the invisible killer, which is radiation storms,
Mhm.
and also the, you know, these big radio bursts. I think space weather gets blamed for a lot of stuff that it shouldn't get blamed for.
Mhm.
For example, recently the you know, the plane that
Right. Yep. Yeah, the Airbus thing.
the Airbus, yeah, exactly.
Yeah.
You know, and it's saying, well, there was this space weather event that took it out, and I, you know, go back and it's like, no, there wasn't. There's no space weather event. And it made news. Of course, all the people on YouTube went crazy for the whole Airbus thing and saying, oh my gosh, the space weather tells you how bad it is. It grounded 6,000 planes. That's like, okay, guys, first of all, what grounded the planes was the fact that someone probably saw the radiation storm software loop in there, and this had this protection mechanism, and read this software routine and went, this doesn't need to be in here. Let's just get rid of that. We don't know what
Yeah.
that's for. Just get rid of it. And then when they realized, oh, somebody got rid of something, let's put it back in. You know, that's what made them have
Yes.
to ground it.
Yeah.
And the other thing is that, you know, the sad thing is that space weather is unlike terrestrial weather in the sense that not everything that happens right when the event happens. So we
Yeah.
get both, you know, instantaneous responses, but we also get these integrated responses that take time from when the original hit happened. So we almost call that space climatology.
Mhm.
And half of, you know, the stuff that we get from radiation storms and, you know, end up being part of that bucket. So we're not even sure, when you talk about this Airbus thing, whether they just kind of blame space weather for the grounding, just because it was convenient and because nobody knows it and because, you know, they can get away with it.
Right.
Or because they honestly don't know. Let's just blame something. Give me something to
Yeah.
blame. Okay, space weather. Good. Sounds good. No one's gonna be able to dig into that. They won't, you know,
Yeah, you're right.
Fine.
They can't ask AI about it.
Right, exactly. Well, it's plausible, you know.
Yeah.
So, right. Or you actually had something like cosmic ray hit, because, you know, the only radiation storm that you had was like 2 weeks prior to that, and it was just this little bitty thing. It really wasn't even, I think it was, I'm not even sure it went to an S1 level. It was pretty
Mhm.
low. And yet you can get these big cosmic ray hits. Even during solar max, you can get cosmic rays. But whatever happened, if it was something that impacted the avionics of the aircraft, and there is a chance that it could have been it affected a state in the avionics that wasn't accessed right
Mhm.
away, right? And so when the plane finally found a situation where it needed to access this particular memory or this particular command or this particular location in the semiconductor, then it found this, oh my God, this corrupted sector, and crap, you know, basically had a problem. It could have been that, or it could have also been something that it corrupted a little bit. But that corruption then, as it continues to be passed forward,
Mhm.
makes something else corrupt, and then makes something else corrupt, and that corrupts something else. And it just keeps adding until there's so much that's corrupted, right? It becomes a propagation of error, that so much is corrupted that the whole thing craters. And that is very classically space weather. But it's super hard to pin it on space weather because it isn't simultaneous with the event itself.
Okay. Yeah.
And that's something that I think, Tanya, that has super massive implications for medical devices.
Hmm.
That it may be extremely hard to understand how many medical devices actually, when they malfunction on the ground, whether or not you should go to that person and say, okay, you had a device that malfunctioned, whether it be a pacemaker, whether it be a pain pump or whatever, all these different devices that we're building all the time. And you almost have to say, can I look at your flight records?
Yeah. Yes.
Because if they had flown recently and there
Yeah.
might have been an inclement situation then, I mean, it might behoove medical professionals to do that, or even the device manufacturers to consider those types of things, that
Mhm.
space weather is going to be something that sneaks up on you.
Yeah.
I think that to me is the takeaway for that particular event. And that's to me something pretty, that's pretty amazing. But I don't think anybody's thinking along these lines.
Right.
And they really need to be.
No.
Yeah, that
Because
actually tied into one of the other questions we had, which was kind of about this. It's like how this goes beyond Aurora and it goes into like aviation and things like that. And but the end of this question was give like we're saying, the infrequent nature of some of these events. It's like, is it important for the general public to know about the space weather? And let me move my thing over here. Yeah. And does the correct terminology really matter?
correct term, well, say correct terminology, I'll flag that one. I guess I'll answer the question in reverse.
Yes. Yep.
The correct terminology really depends upon which terminology, right?
Okay.
So
Yep.
CME or solar storm probably doesn't matter,
Yeah.
right? Layman vernacular versus the scientific vernacular. So
Hmm.
that doesn't matter. But if you're conflating a solar flare with a coronal mass ejection,
Yes.
absolutely. And this is something that I gotta get on Vince Ledvina's case for, because he uses Twitter's forced word economy to talk about the X class.
Hmm.
And it's like, no, don't do that.
Yeah. Yeah. No,
I know
don't.
you know the
Yeah.
difference, but don't
Yeah.
do that, because
Yeah.
a lot of people don't. And so
Yeah.
they'll start talking around and saying, well, Vince said it was okay that, it's an X class CME. It's like,
Yeah. It's like,
no.
oh no.
Because it then green lights people to say that they can conflate the two, and the two events are the same. And then when they start saying, well, wait a minute, the solar flare already impacted? No, the solar flare is going to arrive in 3 days. And you're like, no, the solar flare hit when you saw it.
Yes. Yeah.
This me is going to arrive, and be, people end up getting confused that how can a solar flare drive a radiation storm? It doesn't drive it. It creates the seed population. The CME drives it. Well, aren't they the same thing? No.
Right. Yes. Yep.
No, because a radiation storm is very different if it's a solar flare than if it's a CME. Very different radiation storms. So yes, they're different phenomena. And when people begin to conflate the two, then what ends up happening is that they get all of the effects at Earth wrong.
Hmm.
So there are certain terms that you can use simultaneous, or interchangeably, and that is the layman's vernacular for for a particular phenomenon, and the scientific word for it, or phrase for
Okay.
it, name
Yep.
for it. But don't conflate the different phenomena. Do not interchange solar flare and CME, for example. That's very bad. Filament and prominence is another one. People will
Yeah.
use the
Yep.
same word for both, and okay, but there really is a fundamental observational difference between the two. That's another one. What do people who use flux rope way too much? Filament is a flux rope, a CME is always a flux rope. Any part of you're hitting it is a flux rope, but flux ropes have a particular, it's like, okay, no, not everything is a flux rope.
Yeah.
Flux ropes are, that's where what a CME might try to relax to, but it may not be a flux rope, or the part that you're hitting may not be the flux rope part. So
Okay.
there are, there are limitations to how much you want to be careful and not be careful with your language.
Yeah, that makes sense. And then I guess we'll keep tying into this subject a little bit is so how can professional or and amateur space weather community work together to spread valid information and not be drowned out by the hype behind it.
Wait, say
And
that one more time. I was thinking, because we had another part of this, of the prior question that
yeah,
we missed, but we can go back to that one. So
yeah.
this new one is what is this one?
It's basically how can the professional field and to some extent the amateur people uh
Citizen science folk.
yeah, in the
Whatever.
space weather community work together to spread valid information and not be drowned out by all the hype that's created around it.
You can't.
Okay.
That's simple. Just ask any
Yeah.
terrestrial meteorologist. But that's okay. That's
Yeah.
okay because as we're learning through, looking at terrestrial meteorology, what you're doing is making the audience smarter. So
Okay.
by
Yeah.
doing that, people begin to recognize what to look for and what not to look for. And
Okay.
and to be totally honest, it's okay that we're not able to outrun the hype,
Hmm.
because the hype has a machine that's gobbling it up even faster than us. So we get all nervous that we're being gobbled up by the hype, right?
Yeah.
And cannibalizing us. But to be totally honest, we're actually, as I'm seeing things unfold, we're actually in a much safer zone. The hypesters, the grifters, they're in
Yes.
trouble because AI is going to do it much better than they can.
That's a good point.
Right. So you guys see, and so where the question becomes, fighting, for instance, let's talk about Aurora, since this is,
Yeah.
predominantly Aurora talk.
Mhm.
All of you have had experience with AI generated Aurora
Oh
imagery,
yeah. Yep.
Oh God, yes.
right? Some of it looks fantastic, and some of it looks like a brown Cinnabon in the sky.
Yes.
See that one? Lord.
Yeah.
And right now, we still get National Weather Service folks and other, reputable agencies, sadly, retweeting that crap
Yeah.
all over, as if it's real. The nice thing is that pretty soon they're going to be, there's going to be so much of that out there, and they're going to be burned enough times by real folk going, "Oh, you guys are stupid. You just lost your street cred."
Yeah.
Right?
Hmm.
That they're going to start going, "Okay, well, I need to learn how to tell the difference because there's so much AI generated stuff. There's so much hype. I have to, before I look at anything, I have to stop and scrutinize."
Hmm.
This is where we shine, because all the hypesters, if you scrutinize the hypesters, you find out they're wrong. But
Yeah.
if you scrutinize us, we'll stand there all day and take it. All you do is make us look
That's
shinier. It's
fair.
like taking a rag and
Yeah.
just polishing us up, because we're on it. You can scrutinize us. We are clinging to the truth. And so we start shining as bigger and brighter beacons of light in this AI manufactured misinformation, nightmarish, grifting universe that is social media. So I
Mhm.
don't think we have to do anything other
Okay.
than what we're doing. The people are going to start seeking us out.
Okay.
Does that make sense?
Yeah, it actually
Yep.
does. When you put it that way, it really does, because it's like, yeah, people do get fatigued by it, and then it might take some time, but it happens.
We
So,
should find it. What would be a good phrase? I think that's a perfect word. It's
mhm.
not AI fatigue. What is it? What is not grifting fatigue? It's not a space weather fatigue. What kind of
Yeah,
fatigue? We should come up with a name for it.
yeah, we should. Yeah.
I think that'd
Because
be
that's
great if we come up with a name.
because that's what it is. You just get tired,
Yeah.
it's like it's just too much, and it's overload, and you're looking for what the actual story is when
Hmm.
it's surrounded by all this junk.
It's, and I can think, of course, in my area, the fatigue I get is the micronova, the kill shot fatigue.
Oh, yes.
Fatigue, right?
Yeah.
But for aurora photographers, what is it? What is it, in what fatigue? Is it AI fatigue? Is it AI aurora fatigue, or
Some of it's AI, and then, for me personally, some of it is maybe it's anticipation. I get it, people are really excited about stuff, but you get excited to the point where it happens and then it's not as good as it was.
As you
And then like,
expect it. Yeah.
yeah, because you expected it to be really great and it was kind of meh.
It's white. It's white.
Yeah.
It's not, it's supposed to be blue and green and yellow and
Yeah.
purple, and it's white. It looks like clouds. What am I looking
Yeah.
at?
It's like, what is this? So I think some of it is that it's like there's this built up like it's going to be this great, you know,
Technicolor show. Yeah.
yeah,
Yeah,
and
but
Commenter said hype fatigue for the word. I like
yeah,
that too.
Fatigue.
hype
I
fatigue. Yeah,
I
That's a good one.
I really like that term because with all the forecasts out there and sort of confusing what the forecasts are really for and what they're trying to predict, as opposed to, yeah, this is really for Aurora. When it's a miss and it's been so hyped, there are people that will spend a night in the field waiting for something to arrive, and sometimes nothing shows up. People will drive crazy hours. They will stay in parking lots and they will spend a night in the parking lot, sleeping in the car, waiting for something to show up. We have dangerous weather in upper Midwest that's basically moving in. It's going to be something minus ridiculous degrees and wind chill, and
yes,
I bet some people will go out trying to
Oh, I'm
chase.
sure of it. Oh, I'm sure of
Mhm.
it. Especially for this, if it's rated at, I don't know if you guys have looked at the NASA, the M2M,
hmm
models that come out so quickly. They're talking about, KP of 8 and 9.
right,
And I'm thinking, not 9, guys, come on.
yeah,
G5 from this? I don't know. I don't know if it's
Well,
G.
that's just model
yeah,
output, and SWIPC doesn't actually use the KP. They go more with climatology. So I
Agreed.
won't I
hmm
won't be surprised if G3 watch is
Sure.
posted.
Oh, sure.
yeah,
G3. Yeah. I don't know if
Yeah,
I don't think they'll go far. Well, they never will put out a G5. Swipsy will never put out a G5. They'll
right.
put out
mhm,
a G4. They'll call it a G4 plus, but they'll never do a G5 for that
yeah,
exact reason. They
hmm
do not want to incite panic. Now,
right,
could I see a scenario in which they put out a G5 watch? Sure. Sure. If there was a Carrington class event and it was
yeah,
clear to everybody on the planet, I mean, sure, I could see them doing it, but for pretty much every conceivable scenario other than that, they're not going to put out a G5
hmm
ever. But and that's kind of part of the reason why it's like I appreciate NASA's M2M models putting out their content, but stopping short of a KP of 9, I think is probably, at least if it's going to be on a public facing
mhm,
web page, probably would be wise to
yeah,
I think it's just
instead of
taken
putting a 9, how about an 8 plus?
I think it's just taken out of
yeah,
context completely
yeah,
because
Well,
this
that's
is
what the public does, right?
yeah,
yeah,
exactly.
Especially the grifters. And so all of those guys have access to this stuff because NASA forces that, and that's fine. I don't have a problem with people having access with that. But
hmm
there's, we have to understand what the consequences of that. And I think it does. I
mhm,
think Chris, whoever the
yeah,
person in the chat who mentioned hype fatigue, I think that's absolutely spot on. That lends itself to hype fatigue because these grifters go, see, I'm quoting NASA. NASA says 9. NASA says
hmm
G5. And it's like, no, NASA's not saying that. That's just an output of a model. But it's on a NASA
hmm
website, so therefore it says G5. And all the
yeah.
trolls go,
hmm
oh,
Yeah,
So
and just about any CME that's coming with X-Flare, somehow somebody will ask, is it another Gannon storm?
Yeah,
Because that's kind of the standard at this point of really massive event.
it's it.
So
It
mhm,
is, isn't it?
yeah,
Like
that's
it's like,
it.
is it a Gannon? Is
Yeah,
it, is it like the one in May? It's like, no.
yeah,
That-
no.
So, hype fatigue is something that I believe is, I think the Aurora community suffers from it far more than any other space weather stakeholder. Simply because of the chances of going out and seeing Aurora and the fact that you guys are nuts. You guys are absolutely nuts. You'll go out in frostbite weather and stand in the cold and try to, deflect moose charging at you and coyotes and wolves that are baying in the distance. And I'm like, man, you guys are just, wow, you just built of something else, some incredible stuff.
Yeah, we've
That's
been
what,
accused of being a little crazy sometimes.
guys, it's just, And I mean, I love it. I love it. I'm my, you know, I have nothing but respect for everything you guys do and that you're willing to do for either the shot or for the experience because of your
Yeah.
love and your passion for it. But there are others out there who want to have that same passion, but they don't have the skill set, and they'll go out there and maybe get frostbite, or they'll go out and drive accidentally off into the snow because their GPS says the road should be here. So they'll turn left and now they're stuck in a 6-foot snowdrift because Aurora is real close and they don't know that their GPS will scintillate. Their signal will be all over the place. So they get stuck. And now it's 2 a.m. They're in a freezing car, right? That's stuck in the snow. And how the heck are they going to get out of this? I mean, it can suddenly become a life or death experience if they're inexperienced and, God forbid, go out on their own.
Yeah. You're
Yep.
absolutely right.
Yeah. So,
Well, I
you
know.
know,
Yeah. Well, I know we got kind of out of order with these questions, but it was so it's because like they kind of take a life of their own. You know, you start to answer some of them, and so I'm like, so we'll go back to this one because I think this is a little different than the rest of it. But like, what are the most common inaccurate portrayals of space weather have you encountered in either movies or media coverage?
oh gosh. Well, the obvious most fun ones are the rocks, the burning rocks from space, right? Because
Yes, yeah.
the space weather is nothing but meteors, right? Because then people think of the typical Hollywood script writer is thinking space weather. What is space weather? It's weather from space. What do I know that's weather from space? Well, what do I know? That comes from space. Oh, meteors, right? Yeah, and they light up, right? They light up in the sky and they rain on you, right? And this is weather, rain, meteor rain, right? Now, if they come from the south, that's what a CME is rain from space from the sun, but the sun is red and it's fire lava stuff. So the rocks have to be really hot. They have to be really hot and on fire. Fire rain. Whoa, this is crazy. Yeah, fire rain, that's space weather coming down from the sun. This is a storm. Oh my goodness. Yeah, now let's have it blow people up. Right. Like it's big rocks from space on fire blowing stuff up. That's a movie. That's space weather. I'm done.
I'm
Right?
laughing because that's exactly
Yeah.
what my colleagues actually
Yeah.
were thinking when I started to talk about, space weather. Like, well, it's very dangerous stuff. I'm like, okay, what is
Yeah.
your impression? Oh, they're like, it's going to be fires everywhere. Probably not. But those movies, they do penetrate into sort of general public impression of what space weather is.
Right.
And yeah.
Yeah. That's the astrosociology part. It's incredibly
Yeah.
powerful because the space is, right, it's the final frontier. I mean,
Mhm.
Captain Kirk told us so. It's the final frontier. So we go out into space boldly and we don't know what we're getting ourselves into. And so everybody, who's even remotely interested in it, as they look up in the night sky and really can't make out, don't really understand all the different phenomena that occur out there. Anytime they see documentaries about space or movies about space, they're going to pivot and go, ooh, I could learn something from this. And that really is astrosociology. It's the heart of it.
Mhm.
And people internalize this junk food, this junk science. And now the grifters that are becoming, who also have grown up on the junk science and now are peddling it, is almost space porn, right? Space weather
Yep.
smut. That's what you call it. Space weather smut.
I mean, it's an accurate description.
Right. And it's a cheap magazine you stuff in your pocket and walk around.
Yeah.
Going home to read my space weather smut. But it's it's got all of that same kind of impression, right? That it's super exciting for a very short period of time, but there's nothing real of substance to it. And people don't even realize that they ingest it internally and subconsciously. And yet, when people then talk about space or space weather, they pull that same smut, they open that same magazine and start reading from the stories there. And it causes them to be completely confused and scared, to be quite honest.
Mhm.
And I think that's the biggest thing that we have to get over still, is people are plain and simple scared of space weather. They're just scared.
Yeah.
And how dare you talk about it, because you're just frightening people. I don't care. Don't talk about Aurora. G1 storm. I don't care. I don't want to hear it. La, 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 la. You're going to scare, and you should just shut up. Just stop. I mean, I can't tell you how many times I've had people tell me that, like in the comment section or something, where it's like, I hate you grifters. You guys are just you're all sensationalists and you're just scaring people for no reason. And I'm like, that's odd. I was talking about how quiet the space weather was in my forecast.
Yeah, like weird.
Did you even watch it?
Yeah.
They just don't want you to talk about space weather at all, because they've been so petrified about it that they think that's, anybody talks about that stuff, that's all that's there.
Yeah.
And those are still some of the walls that we have to break through. But I think that's coming. I really do. So I don't know how I got there. Sorry. I kind of
No, it's all good.
Did I address the question at all?
Yeah, I mean, you did, because like that's pretty accurate. Like the media and movies have really, I mean, you get it to some degree because it's supposed to be entertainment, right? And disaster movies always everything's got to be grand and and scary and all, and so you can kind of see why it went that way, for entertainment. But the problem is a lot of people take entertainment and kind of think it's fact,
Right.
especially science fiction, because so much, we talked about the AI stuff, right? And how this seems to be like coming true. And it's like, so there's like these little underlying truths in there. So people just believe like, oh, it's entertainment, but it's real.
Yeah, and CGI is so dang good, right? That
Yeah,
it looks
right.
real. And that's
Yeah.
good enough. And there's no pushback. What
No.
pushback are you getting outside of our little contingent of space weather,
Yeah.
experts? There's no real pushback in the general populace.
No.
So that, again, that's coming. But until we get there, yeah, Hollywood is still going to dominate that arena. And it's amusing.
Yeah.
And sadly, I've seen some of that in AIs as well, because they suck up everything, including the junk food, and they get things wrong all the time. That's why I actually tell my students, don't trust AI. You can go look at AI and talk to ChatGPT or whatever about your space weather phenomena, but don't trust everything, because it devours the same junk food that everyone else does. And
Yep. You still got to fact check it.
Yep.
And that's the one thing, because like, I remember you saying that in class too, because it is true. Like you put in the chat GPT and then you can be like, no, that's wrong.
Right. It's like, oh,
Yeah.
I see where you're going with this, but that was only under this condition with this assumption, and that over here, and this has to have happened first. It's like, all right, you obviously don't understand context, and so ChatGPT can be right in certain, a lot of the time, but when it's wrong, it can be wrong in a way that it would never, you'd have to sit there and argue with it. And trust me, I have. I actually talked to, that's how I know we can get these wrong answers. I know when students are using ChatGPT to answer questions, because it will come up with things like when you use the word radiation, just using the word radiation, right? Radiation in space weather, you always have to indicate, and this goes back to that language things, like how can you use different terms, or can you be lax in your terminology? Well, not really. And here's a perfect example of when even a single word, you have to be very, very selective in how you're using that word. And that word is radiation. Because in space weather, you have photonic radiation, light radiation, as well as particulate radiation, right? Both of those come from solar flares, as well as other phenomena, right? Because you can emit light, electromagnetic light, which includes radio bursts and X-rays and gamma rays and all the way down the electromagnetic spectrum. No mass, right? Those light rays, that light radiation is non-ionizing. Right? Whereas, am I saying that right? Whereas when you have particulate radiation, right, you can actually, you're going to get destructive things that are actual particles that are literally going to rip things out of their deposit charge and rip molecules or parts of a semiconductor, rip it apart, all sorts of things. You get a totally different type of ionization track because the radiation in this case is particulate. And so when you're talking about radiation, there've been times when I have students answer a question about radiation and they put it into ChatGPT, but they're not careful. And so the answer that it spits out is clearly associated with one type of radiation when I've asked about the different kind.
Yes.
But they're both space weather. So, there's an example of where you can get yourself into a really big hole, not recognizing that even a single word needs to be very carefully chosen and needs to have context around it to even understand it when it comes to space weather.
Yeah, you're absolutely right. Because back in the first class I took with you too, because the radiation, I did get mixed up with that because I always thought radiation like, the bad type, but I didn't realize, probably just because you just don't associate it if you don't study it, that light is radiation too. And then there's like heat radiation. And it's like, so there's all these different contexts.
And if you go into amateur radio,
Yeah.
they're talking about light radiation, and they don't mean radiation from the perspective of visible light or gamma rays or X-rays. They're talking about light radiation from radio waves, because radio is light. Radio waves are light. It's just a lower frequency of light. So from that perspective, then you have to deal with the fact that different stakeholders in space weather are going to look at radiation in a different way. And so there have been many times when I've caught myself confusing amateur radio operators because I'm talking about particulate radiation and they're thinking radio waves.
Right.
The radiation that comes off a microwave dish, for example. I'm like, no, not that kind, not that kind.
Like, no, different kind.
Yeah. So it can be, it's really, space weather is a neat place because it's where a lot of different specialties intersect. And a lot of things that you that even the specialties don't make room for, like the word radiation. They're like, radio amateurs, they own the word radiation. We know what we mean when we mean radiation. So we understand space weather. When you talk radiation, we completely understand it. It's like, no, no, you don't.
Right.
You gotta look at it from this perspective, and then people from a different perspective, the optical perspective, or just from solar, well, no, I'll say from an optical perspective, look at radiation differently than people who are like looking at radiation belts here in the Earth's the magnetosphere. They'll talk about radiation and they'll just use the word radiation because to them, the only kind of radiation is particulate.
Yeah.
Worry about any other kind,
Yeah.
It's always particles, right? It's everything.
Yeah, always.
So it's very interesting watching different disciplines that cross over when it comes to space weather impacts. Cross over and talk about this stuff because you can see them. You literally can see where they, get tongue-tied and trip over each other's shoes. And that's, it's super important that you guys are able to, have the experience and the knowledge that you have to be able to stop, prevent basically that from
that
from
confusion.
people, falling over themselves that way. That's why you're here.
Yeah. Yes. Well, let's see. So these next two, I think I'm going to combine them. We'll see if I can do it because it's kind of about talking about tools and visualization.
Oh, wow. Okay. And you guys do realize we've been on for 2 hours.
I
Right?
know. I know.
Is that okay? I mean,
Yeah.
Your audience is going, will you just stop this for God's sake?
I mean, usually we look to see if anybody's, tired, but a lot of times, surprisingly enough, the people that, watch this, like they're usually there the whole time because it's
We have the same amount of subscribers now watching as we did when we started, if that helps.
Okay, good. All right,
so
good.
there you go.
I just wanted to do the litmus test, kind of.
Yeah. So I'll see if I can combine these two a little bit because it's like because we talked about hype and we talked about the news outlets and stuff contributing to that, the hype and disappointment because of you know aurora forecasts that don't pan out, and they tend to use the visibility maps and things like that for that like aurora is going to be seen down to here.
Yeah.
So the main question to that is, are there any tools or visuals that can help tell a more accurate story? And then I roped it in with how you have that new CME visualizer of yours.
Right.
And And like, can that be used to help make these predictions a little better because of the magnetic structure that you're
Yeah,
able to kind of, you know,
that I
show in that?
that I ad hoc insert. Yeah,
Yeah.
okay. So ultimately, yeah.
Mhm.
And the reason why I'm balking is only because you've asked two questions that really address two different sides of the storm, of
Okay.
this solar
Yeah.
storm, right?
Mhm.
Because when you're talking about the aurora and Earth and how to predict, how well the predictions are done there, you're talking about an Earth impact that really doesn't is a totally different animal. That can't be predicted by just looking at a magnetic structure coming from the sun, because
Yeah.
the Earth has to respond, and it responds in its own way, right?
And it
That's the
does.
second chef. Right? We talk about
Yep. Mhm.
so the CME coming, the ICME coming, the flux rope, whatever structure coming. That's the first chef. The second chef has to then take that and crack it and spin it around and scramble it up. And so the Earth is going to have its own its own response that is not just complicated, it's also built on what happened prior to.
Okay. Yep.
Right. So preconditioning is an overlooked goodie. Most people really overlook the importance of preconditioning.
Hmm.
And what I mean by that is, has Earth been storming a lot recently? Where is it in terms of its mass storage? And I'll tell you one way of kind of looking for that.
Okay.
And then, or how has it been quiet for an extended period of time?
Hmm.
And what's the mass storage related to that? And the reason why I talk about mass storage so much is because in a very general sense, when we talk about the Earth's magnetic system, right, and we talk about the tail, if I've got, oh, look at me, I have my little Earth right here. So always the teacher. So I don't have my slinky's in the other room, sadly, but this will be
Yeah.
good enough. So if the sun is shooting the CME's this way, right? Solar wind's blowing this way. Here is the back part of, oops, let me point it this way. So sun is coming, solar wind's coming this way.
Hmm.
Here is the back part of our magnetic field, right? The heart of the Earth's magnet. You got two lobes, right?
Yep.
So here's the back part of this lobe. And of course, as you, and I'm just going to hold this ball, this thing gets stretched out, right?
Yeah.
And this becomes the slingshot, right? And you look mass load, mass load, mass load, and eventually it gets pinched to the point where it kind of breaks, right? It reconnects and then slams everything forward as it dipolarizes. Well, the mass loading is what is going to dictate to a great degree how far pulled back this thing is. So if you're sitting in a situation where the Earth's magnetotail, right, is just kind of hanging out like this and not really all that bothered, then you can have a small ICME hit Earth, and it will cause this thing to stretch back, stretch back, stretch back, stretch back. And then if the CME stops loading, then it just kind of sits here and maybe slowly leaks back. Okay.
Okay. Yeah.
And you'll get some substorms, a few that release a little bit and release a little bit, but eventually it just kind of comes back and it's not a big deal. So you end up getting no storm.
Okay. Yeah.
And so you go, oh, okay, well, that CME wasn't strong enough. It wasn't great. It wasn't good enough to give us anything. But let's say you have another storm coming, and let's say it's weaker than the one before. And so everybody's watching this storm going, oh, well, the last one was stronger than this, and now this one's really weak. We're not going to get anything. But meanwhile, in the situation of the Earth, let's say we had a really decent storm.
Hmm.
Okay. So or not decent storm, but a decent mass loading. So let's say the solar wind was like slightly southward for a long period, and it kind of mass loaded. And so this slingshot got way out here. So now it's way out here and it's really sitting here. So then this ICME hits and it mass loads a little bit more and then goes like this. And suddenly we get this massive release, massive aurora show, and everybody's scratching their heads going, what happened?
Yeah.
This was supposed to be a dud. This was weaker than the storm before. Why are we getting such a big aurora show? Oh, I don't know. Enjoy the aurora. Okay, folks. Right. And so that's the problem, is that just looking at an ICME coming, irrespective of its magnetic configuration, just trying to gauge how the Earth is going to respond from that is not a wise decision.
Yep.
You need to kind of have an idea of, is the Earth ready to storm or not? And Part of that is guesswork. Part of that is just looking at the history of, how much storming has happened recently. And part of that is kind of getting a feel for where is the ring current? How built up is it right now?
Mhm.
That's kind of hard to tell me. You can look at it to some degree by watching DST, right?
Yeah.
But another maybe quicker way is look at on SWPC's page, and this isn't perfect,
Mhm.
but look at SWPC's page and just look at the radiation belts. Not that I'm saying the radiation belts are the ring current. They're not at all. You're looking at two different particle populations. But what you can much of the time ascertain is if the radiation belts are built up a lot, that means the ring current is probably pretty well mass loaded.
Okay.
Because the ring current is the source population for these particles that are getting accelerated and raising to higher energies. And so if you've got a really high level of electrons, the energetic electrons at SWPC's site, if you're seeing them above the two, that they've got a threshold of 2 MeV threshold of flux level, that then signals to satellite operators in geo that they could have spacecraft charging. You won't use it that way, but what you use it for is, hey, is the Earth maybe conditioned to storm? Because if you see it up that high, well, then likely there's a lot of particles in the ring current. And if a storm hits, if an ICME hits while we're up like that, you'll see all those storms drop. You'll see all the particles flush right away. You'll literally watch, and I call it flushing. This is what I call flushing, right? And you guys remember that from swim.
Yep.
Particles will flush out. But in the process of doing that, right, there's going to be a lot of particles that are changing, a lot of reconfiguration, and it's likely because you're getting this storm hitting and this slingshot's way out here, and it's going to slam forward and cause a lot of aurora. But if you see that the particle levels are super low in the radiation belts, well, there's less of a chance that you've got a heavy mass-loaded ring current and a mass-loaded magnetotail, right? The lobes of the tail coming in. Does that work all the time? No, nothing works all the time. Because that's only one of many different factors, right? There's a lot that goes on with how the magnetic field is configured and how it's interacting at the magnetopause, at the bow shock of the magnetopause. That makes a big difference too, how you get particles in. Obviously solar wind matters a lot, whether you have magnetic field flipping north-south. Those can, you guys have a good handle on that stuff. Tanya's sawtooth. I know you love those sawtooth.
Yes, she does.
No.
Over and over again.
Every 3 hours and green glow in between. Yeah, that's a lot of fun.
So, so a lot of, there's a lot of stuff that has that there's a lot of other mechanisms going on and a lot of other circulation and a lot of stuff going on in the auroral oval that plays very significant roles. But prior to all of that, knowing what the Earth's magnetic configuration is, knowing what the particle configuration is in the heart of the magnetosphere gives you a sense of what's going on downtail. And so it gives you a sense of what the preconditioning could be and whether or not Earth is ready to storm.
Yeah. Actually, this whole conversation it's kind of like, I think one of the problems that we're having with Aurora in general is so much is given to the sun side of, like the CME's coming. This is it. And what you're talking about is never talked about, really.
So about magnetospheric circles, but magnetospheric circles, aren't operational typically.
Right. So I think maybe that's where some of the work can be done, is like maybe putting more, at least for Aurora chasers, maybe putting more emphasis on the Earth side, the second chef, and maybe.
Well, they do, but most of them are ionospheric.
Yeah.
So that's the sad thing, is that you get when it comes to Earth stuff, people either look at the sun and care about the sun to Earth, or they look at the sky.
Yeah.
Care about the sky up to the tip, the rim of space. They don't care about really which is the thing that is the dominant player, honestly, in the chef arena, which is the magnetosphere. It really is. Without it, we wouldn't have Aurora at all. you know?
Right. Yeah.
So, yeah, I think that's a very good point you make, Mary Beth, is that
Mhm.
there may not be enough focus in that particular discipline, and it really needs to be paid attention to more in operational
Yeah.
circles.
And I think some of it too comes from the fact that people want, and even in all, I think all or facets of space weather is they want this forecast like, days in advance or weeks in advance. And the reality is we just don't have that or aren't even really capable of it. So,
Can't even see 2/3 of our entire sun. We can't
right.
see, to know our sun, we have to study Jupiter. It's like, really? Jeez, that
Yeah,
sucks.
it's like, wow.
Yeah, but I mean,
Mhm.
as you guys know, I'm in the process of filming a documentary, and one
Yeah.
of the things that people have always brought up the whole concept of gamma rays that are ignited in the sun, that are created in the core of the sun, and then they have to random walk all the way out, and that takes tens of thousands of years. Some people say it's about 10,000, some people say 100,000. Depends upon how the random walk occurs, but it's somewhere in there. So we say tens of thousands, and that pretty much covers the whole gamut. But it's kind of a cool thing to think about, because if it takes tens of thousands of years to get up to the radiative zone, up from the inner core, up to the edge of the radiative zone to where you could actually see the light.
Yeah.
Okay. So then it goes through the convective zone very, very quickly. And then of course it goes from the edge of, and that's in microseconds. And then it goes from the edge of the solar corona to Earth in 8 minutes. Right. But obviously the bulk of it is being spent inside this very dense plasma. So incredibly packed down. This liquid is so incredibly packed down that the poor little gamma ray is getting eaten by its nearest neighbor, and then barfed back out, and then eaten again. And, it just keeps going, losing energy along the way, which creates this beautiful spectrum. But by the time it gets out, and the gamma ray is now brilliant, myriad of spectral colors from, that runs the whole gamut, and it reaches Earth. What's cool is that you can look at that during like a rainstorm, right? And you see this gorgeous rainbow. And this is something I talk about in the documentary, that if you think about it, the coolness of that is that every rainbow that you look at, every rainbow you see, is tens of thousands of years in the making.
That's pretty cool. Yeah.
So even though we can't see down into that radiative zone, and it makes trying to understand our solar dynamo and space weather much more frustrating, it has some really interesting consequences that allows you, every time you look at a rainbow, you're looking back in history, right? You're looking back. Yeah.
That's pretty cool. All righty, so let's see. Okay, so solar cycle 25 has excited and frustrated Aurora chasers. Um, it seems most activity happens on the limb, or active regions wake up and launch CMEs as they move out of the firing range. Are there hot longitudes where regions are more likely are to become active, and what drives that increase in activity?
Yes, hot longitudes are once again a phrase I coined. I'm very terrible at it. Earth strike zone, hot longitudes. I come up with phrases just because they're easy, right? They're very intuitive. So I use them, and they've caught on. And I'm very grateful for that. That means I'm doing something right. And so hot longitudes arise because of the Rossby waves that are under the sun, or under the surface of the sun. We know that they're there. I mean, and we have them here on Earth all the time. In fact, Scott relays that really wonderful story with how he discovered Rossby waves were on the sun, because a terrestrial meteorologist came into his office when he was doing some analysis, some wave analyses. I think it was Fourier analyses or something. And the guy looked at his analysis and said, "I didn't know there were Rossby waves on the sun." That's how
It's like
signature, stuck out. And Scott goes, "Huh?"
Yeah, like what?
Yeah, exactly. So that's how he really started chasing Rossby waves, and recognizing that the sun has much more in common with other planetary bodies, and even with our Earth. Not so much in the rock, right? Because our Earth is a rigid rotator, but in our atmosphere, because our atmosphere is a fluid, right? Just like the sun is a fluid. That's why we study Jupiter or Saturn, to understand some of these patterns, because they're like the sun, they're completely liquid all the way around. And well, their cores are, and then they've got some type of fluid, their atmosphere is fluid all the way around. and liquid is a fluid. So the sun behaves to a great degree the way, any fluid does, magnetized fluid anyway. And so we see those same phenomena popping up. But with Rossby waves, which are well understood, it's always something that it becomes circular because of a circular motion, because of the rotation of the sun.
Mm-hmm.
And it has to do with, on Earth, it has to do with the geographic, like it's a wave that's been created by, when you rotate, you're going to create convection of the fluid. And if there are topographical or geographical landmarks like mountains that come up, well, that fluid has to fly over that mountain.
Okay.
Right?
Yeah.
It's going to fly over that mountain, and that creates a wave. And that wave continues to stand. So as this thing rotates, you start seeing this wave just continue to propagate. So there'll be these regions in and around a sphere where you'll have Rossby wave excitation modes that will come here, here, and here, let's say. Not always, but in different places. And they'll stay there for a set of longitudes across that disk. If I grab my ball again. So let's say there's Rossby waves up, it's really close. Rossby waves up at the top third, Rossby waves down here maybe, and then maybe Rossby waves on this side. And so there's going to be a set of longitudes that will be, let's say if you're looking down, if this is down at the sun, let's say from the North Pole, and the thing is spinning, right? Or this way, rather, I forget which way the sun spins. At any rate, you'll have a set of longitudes where Rossby waves will be active. And that will stay like that. So even as the sun is rotating and spinning, again, you can't really see the sun spin here, but as I rotate the sun, the Rossby waves will still stay in this set of longitudes. So even as you spin the sun, they'll still stay here. So the sun, in a sense, spins over. So what is it? Takes these active regions on the surface over. They'll literally rotate over those hot longitudes, because that's where the Rossby waves are active. And that will bubble up other magnetic structures that then get entangled and, happen. But those longitudes are not fixed. They themselves rotate slowly, and then they die. And then they come up in new sets of longitudes, which also then slowly rotate. So knowing exactly where these longitudes are going to be at any one time is still a mystery. And part of that's because we just can't observe our sun well enough. And that I don't think has to do with the radiative zone, like penetrating all the way down. That just simply has to do with the fact that we do not have eyes 24/7 on all sides of the sun and the pole, right? The snapshot we get of the sun is not a snapshot. It's a rollout in time. We get the front side of the sun, and then as that sun rotates over us, we get a full view of the sun all the way around 360 degrees, but it takes 27 days to get that map.
Yeah. Yep.
And therefore, the start of the map, that data and what the sun looked like, is 20 to 7 days earlier than the last part of that map. And that is not a snapshot in time, right? So we don't get a good view of what our sun looks like and how it evolves, because it evolves faster on timescales faster than a 27-day map. And that confounds our models. And until we get a way of getting a constellation, probably 3 spacecraft, basically 120 degrees apart, so we get some kind of like equilateral triangle where we'll be able to get overlap, and all of the spacecraft will be able to communicate to us. Maybe we'll have one slightly higher off the ecliptic plane if we can, and have it be higher so it'll get the North Pole, and one of them will be lower and it gets the South Pole a little bit, so that we get a little bit of that information as well. Then we'll do better. We'll do a lot better, I think, at all of this. But that's decades off yet, I think.
Right. Yeah. So I guess that leads into the next one is, what should we expect from the sun and our forecasting methods, which you kind of talked on a little bit. Like, will our skills and instruments improve in the coming years? Again, kind of like that. It's like what, maybe just getting more out there, and
it's the sparsity of data. It is not a quality of our instruments. It is not, oh, this space, stereo's tired. It telemetry sucks, or this imager needs to have better resolution. It's not that. I mean, that helps. You can see how Solar Orbiter and Parker Solar Probe have helped immensely in our understanding the way the solar wind works. But
Mhm.
that's, and how the sun's, magnetic configuration changes and on what scales. But that will help the physical mechanisms, but it's not going to help operations nearly so much.
Right.
Because the thing that's holding up operations is having real-time simultaneous imagery of the sun 360 and the poles too.
Mhm.
And if you were to ask an operational, if there is such, an operational magnetospheric physicist, they would say the same thing.
Okay. Yep.
Our models of Earth's magnetic system is never going to be perfect in terms of knowing when aurora onset is, knowing when, if a substorm is going to fizzle or if it's going to really go, knowing when there are pseudo breakups happen, knowing when, all of the different types of aurora that can happen. Knowing the coupling with the neutral atmosphere and when we get these radical shifts in convection patterns in the auroral zone during north-south turnings,
Mhm.
how those affect everything and what to expect down on the ground. We're never going to understand that until we get simultaneous observations.
Yeah, that makes
large
sense.
different swaths of the magnetosphere.
Yeah, that seems to be the ongoing pattern. And anybody I talk to, even like at all these conferences too, they're like, we just need more. We need more.
Yeah, because it's just such a vast system.
Yeah,
Well,
right.
it's like, and it's like the same thing. If you talk to a terrestrial meteorologist
Mhm.
and they want to be able to understand, temperatures like climate change. Why is climate change so damned hard to lock down, right? Why are the error bars as large as the mean, the thing that you're trying to actually measure? Why are there so many conflicting ideas? Well, it's because satellites, when they view the Earth, they have to go vertically through an entire column of air that is, how many kilometers high, right? A lot,
Mhm.
right? And so it's integrating all the way down. You're not getting a single point at a single place. You're getting an integrated column, and that smears out your data. So satellites don't work, even if you have constellations all over the globe, which we do. And if you want to get it from the ground, which is really where you want a lot of this stuff, well, hate to tell you this, Earth is a water planet. 2/3 of it's covered in water, right? So where are most of our instruments? On the land.
Yeah. Yep.
So we don't have global coverage. So we're never going to understand climate change because we don't have enough data in the places that we need to get the data.
Yeah.
It's not that our instruments suck. It's not that our models suck. It's that we have the sparsity of data problem.
Yeah.
And that's going to dog us until we're able to solve these issues. Yeah.
Fair enough. Yep. All right. So if we are looking for accurate and valid information and do not have education or training in space weather, where should we turn to?
Oh my goodness. Depends upon the level of space weather, what your interest is.
Okay.
I would think if it's Aurora, obviously, you two are great resources and you guys are writing stuff all the time.
Yeah.
Informational packets and primers and things like that. And so you cater to the Aurora crowd very, very well. Obviously events is another one. I think he does a lot of blogs that help.
Yeah, he does.
In that regard. You guys should be, and I think some of you guys are working together, creating books,
Yeah. Yep.
Yeah.
That's an ongoing project still. So, yep.
Yep.
So that's a huge thing, right? And then if it's more from, like, let's say, an emergency management point of view, well, I know Jenny made a really nice space weather, Jenny Meehan, who's also a SWIN professor, made a really nice FEMA space weather primer.
Okay.
That I at the moment I don't remember where the link to that is. I have it in my list of things I can get to you guys if you want. But there really aren't any, and please stay away from the grifters. There's a ton of grifters who've written books that are please just don't, just stay away from them. But there aren't really a lot of layman style books that are general space weather purpose. You'll find a lot of primers, but you won't find a lot of books. Although, if you're, let's see, I just got this one. When did I get this one? I know, and I'll just promote his book for just a moment. I have not
fine.
one yet, but Ryan French
Oh, yeah.
Oh, okay, cool.
About space hazards, and I have yet to read it, but Ryan is a great guy, and he's on social media and is a really good communicator. So that might be a place to go. I think it's probably going to read more. Well, I mean, when you look at it, it's actually really nice. Like I said, I haven't looked at it yet, but it's got a lot of pictures and a lot of history, and it might be more than you need. And it probably has a lot of stuff in there that's just space related, not just space weather. But that might be a good place for for the uninitiated. But
Okay.
as far as operational space weather, the way I train it, which is very very geared toward stakeholders.
Hmm.
I don't think a book like that exists yet. Not yet.
Yeah.
So
I don't think so either.
yeah.
So
But I am going to be writing one as I'm doing this documentary. I'm going to have a companion book.
oh,
So,
that's cool. Yeah.
yeah.
That'll be awesome.
Yeah. And the
All right.
documentary is actually going to become a series. I think it's going to be at least a 6-part series. So we got to get the first one done.
Yeah, I don't, and I know how
It's
much
hard.
of a project that is. So I appreciate the work that goes into it.
But it's going to be focusing a lot on on astrosociology.
Yeah,
That's going to be there's going to be very much a human element. It's not just going to be all about phenomenology, but rather our relationship with the sun, and really our relationship, kind of an answer to cosmos. Like,
okay.
if you guys are familiar with
Yep.
cosmos. Yeah.
Well, that'll be fun. I'm looking forward to it.
Hey, yeah, me too, actually.
Yeah.
Or finishing it.
Yes, I bet. Well, I mean, like on a smaller scale, like, we're talking about this book that we're working on too. It's like,
Yeah.
it's a big project, like when you have all these things, and then the feeling when it's finally done, though, it's pretty, it's a pretty cool thing.
And
So,
well, and make sure you actually get the feeling of that, when you are done,
yeah,
because
that's a
get
good point. Yeah.
yeah, you get somewhere and it's like, oh, I need to introduce, oh, right. Gosh, well, we could need to go back and add.
Yeah.
This
Yep.
never ends, right?
It never ends.
You have to figure out when to stop and just say, no, that's going to be book 2,
Yeah.
right? That then gets your mind, it settles your mind. It's that yes, okay, that we're not leaving it out, we're just leaving it for book 2.
Yeah.
Or the next chapter.
Yeah.
Well, see, then that's still book 1.
Yeah. Kind of put a hard stop on it.
Yeah, yeah. But make sure you get a hard stop, because we need those books out there. We
Yeah.
need stuff that's written from truth sayers like you guys, because of all of this hype, because of the hype fatigue.
Yeah.
And people with hype fatigue, thank you for for that phrase. They're going to be looking for books like this. They're going to be
Yeah.
looking for the alternative to the grift.
Right.
And it just doesn't exist yet. So, or it exists, but it's at too high a level. And they're like,
Yeah.
they turn
Yeah.
off before they even start.
Very true. So speaking, I mean, I guess this ties into that. It's like, what are the best ways you found to engage with people who are fearful of space weather? And to add to that, how do you approach people whose point of view do not align with scientific understanding of space weather? So do you find anything that works well for that, or?
Well, it depends. If I answer the second part,
Mhm.
right, that depends upon the phenomena. But
Okay.
let me address the first part, which is, what do you do when people are fearful of space weather?
Mhm.
Typically, what I tell them is, especially because they only are fearful when there's an event coming, right? Like
Yeah.
this, for example, you're going to come across people who are going to freak out, and they'll
Yeah.
come to you and they'll be, oh my God, I don't know what to do. I don't know what to do. And the easiest thing to tell them is, outside of take a breath, okay? All you have to tell them is wait. Just pay attention
Mhm.
and wait. Because all of these storms, they hit Earth, right? I get all this hype, all of these grifters go off saying it's the kill shot, this is it, this is the end, there's a, or there's a transformational shift, the, rise of consciousness, just watch, everything's, it's going to be raining cats and dogs. And then the CME hits, right? And what happens? I don't know, maybe some Aurora,
Yeah.
maybe news articles in the in the thing. If you're an agricultural person and you're precision ag, you may curse the heavens because you can't get your planter or your combine or your harvester to work. for a few hours or so. You know, if you're a drone flyer, perhaps, maybe not. As
Mhm.
you guys, if if you're flying in a questionable area, then things may get a little wonky for you. Maybe not. And outside of that, nothing,
Right.
right? You wake up the next day, the sun rises, you get up, you put your clothes on, you go to work. It's just like any ordinary day. And so that's what I tell people when they're scared.
Okay.
And the funny thing about that is that it may seem cold, because I do reassure them. I don't just say that, but I reassure
Yeah.
them. And then I say, trust me, just
Mhm.
wait. And then you do that once to them and you never have to do it again.
Yeah.
Because you tell them to watch all these people who have gotten them up into a frenzy. And you'll say, look, you'll see when this hits how under control we all have it, because we've been doing this stuff for a long time. Space weather is not new to those of us who work in infrastructure and work, and deal with this stuff. Power grid people know what they're doing. They're paying attention. They've been trained in this.
Yes.
Drone flyers, GPS users, precision ag, they're getting up to speed. Airline folk, these guys know what they're doing, and they have folks in there that know what they're doing. And so we know how to mitigate these things. But it's the crazy grifters out there that make it seem like it's the end of the world. And so when you tell them to wait, you tell them to look and pay attention to the two different groups of people, they really go through a paradigm shift, and they only have to go through it once. But they go from being someone who is sucked into all that crap to someone who will never be sucked in by that stuff ever again. Right?
Yeah.
And I guess I consider that graduated.
Yeah. Absolutely.
So that's anymore how I handle people who are frightened. Of course, I don't leave them on their own, but I let them know that, trust me. And they do. They come back and they go, oh my God, you were so right. Oh my gosh, and now I got to tell my friend,
Like,
right?
it
So,
wasn't that bad.
yeah, and I got to get my friend away from this stuff because they're just as freaked out as I am. So,
Yeah.
and then they say, I'm so glad I found you, blah, blah, blah. And it ends like that. And sometimes those people become the biggest warriors for
Yeah.
the
Right.
space weather, because they were so, they were so swindled by it that they refused to let anybody else be swindled by it.
Mhm.
So that's one of the cool things, is that because they become real big champions for space weather. And now the other thing, when you said, how do you deal with people who have a different perspective than you when it comes to space weather?
Yes. Yeah. Or maybe like different theories or something like that, where things just don't quite align.
Oh, you mean like space weather causes earthquakes?
Yeah. Kind of, yes, along that line.
One of those, yeah, that's one of many.
Yeah. One of many. Yeah.
Honestly, how I deal with it is I never negate what they say.
Okay.
I never say space weather does not cause earthquakes. The truth, because you just use the
Yeah.
scientific method. To be totally honest, we don't know.
Mhm.
What we do know
Mhm.
is that we can't tell right now, because we do not have an understanding of the actual geological drivers, that the primary drivers of things like, in this case, earthquakes. Let's keep on that example for a second.
Mhm.
Because we do not have a good enough handle, geophysicists do not have a good enough handle on what the primary drivers of earthquakes are in terms of prediction. It is impossible for us to know how much of a force space weather applies to
Okay.
this. You could say, we see mechanisms. There are plausible mechanisms, piezoelectric effects, GICs, all these things can cause, we can see how they could cause micro forces. But how much do those micro forces really impact and stress a fault line? We can't quantitatively ascertain that until we subtract off the primary drivers.
Mhm.
But if we can't quantify the primary drivers because geophysics isn't there yet, then we can't reasonably subtract off anything because we don't know what to subtract it off from.
Yeah.
So, and I always use the analogy of draining the bathtub, the soapy bathtub of water. Because I had my kid when my child was young when I started the analogy. So it was like a soapy bathtub full of soapy water. You can't see the bottom, and there's tons of toys under there. And you don't know that because the bath water is clouding them.
Yeah.
Only when you drain out that bath water do you see the toys emerge. And so to me, I was saying space weather is like the toys under the water. The primary drivers are the water, this big bathtub full of water. You have to drain the primary driver out, and then you can have the space weather toys emerge. Those space weather toys are always there. They're always working. They're always doing their thing. You just can't see them, and you won't be able to see them until then.
Okay.
So,
yeah.
So that's how I go about it. I never negate, because most of the time when people are talking about this stuff, they're saying things like that. They're saying things about space weather having a stronger pull on something or stronger effect on something than likely it has. But we don't know that for sure.
Yeah. Yeah.
So until we know one way or another for sure, until we get to a point where we can quantitatively ascertain that, those concepts will stay in the realm of fringe and speculative science and mainstream. It's not that mainstream's trying to hide it. It's just mainstream knows there's no money in chasing it because we can't get a definitive answer. So no one will get funded to do that kind of research.
Okay.
And that kind of satisfies those folks.
Yeah, I could see that. Because it does seem like if you go at them, like, no, you're wrong, or this, like, that just seems to make them more, I mean, I hate to bring, we see it a lot with politics. It's that same, there's no, but it seems like once you diffuse it a little bit, they're like, okay,
Right, right, yeah, you see the wall come down.
Yeah.
Yeah, I always, the neat thing, and I have a very unique relationship with fringe scientists and speculative science in general. I will always have a appreciation for it because, for example, that's how dark matter was discovered, right? The gal who discovered dark matter was really pushed off into the far recesses because they didn't want to give her any projects or allow her to do the research on the more mainstream stuff. So she did some stuff and found something extraordinary, or at least found something she couldn't answer, right? Which made people research it more. And so I will always have a respect for fringe science and speculative science. And the way and I've taken a few bullets for it. There's a few knives in my back. You can probably see. Because of my stance on it. But as I've said, I don't know, probably 100 times, at least in my live streams, over the years, I say that, they're like one hand and the other hand, mainstream science and fringe science, because mainstream science keeps fringe science grounded, but fringe science gives mainstream science wings. And that's pretty much the way I think I will always see it. We need both. We have to have both, right? Otherwise we either never go anywhere, we calcify as a mainstream, as our mainstream science doesn't ask the right questions and never looks up for anything new, or we fly off the handle and go cuckoo because fringe science just takes off with no accountability, right?
Right, yeah.
And we're back to that whole thing, right? This is kind of like a nice little circle back
to
where we started, which is all about accountability.
Yeah.
So
full circle. So the last question.
Okay. Since we've come full circle, this is
since we come full circle, and it kind of is, because it's more about how we have this desire to go to Mars. And what you think the greatest issues are facing that. Radiation storms are pretty obvious, but what kind of I started to think about, like, with these conversations is like, but what about the communication losses with radio bursts and flares? And do we have any guesses on how GPS would be affected on a planet that lacks really an atmosphere and ionosphere? Because I'm sure they're going to want to use GPS location and stuff on things on Mars. So I never really thought about that kind of stuff before until recently. Like, because the radiation stuff is obvious, but this stuff isn't so much, but we're so reliant on it.
Right.
Well,
you recall polar cap absorption events, right?
Yeah.
You know about polar cap absorption events. And they happen when there are radiation storms right
Yeah.
here on Earth. Okay. Well, sorry, I'm just hearing noise.
Yeah.
And you know that part of, the reason why polar cap absorption events are super, impactful is because if anyone is using navigation up there, communication or navigation,
Mhm.
right, it goes wonky because the radiation storm is packed in the upper atmosphere and you're getting a lot of these radiation, these cosmic ray showers, and it's just messy.
There.
Oh, did I disappear for a second?
No, you're good. It was just choppy for a second, but you're still there.
My problem is every time I talk about radiation, that seems to be when the dang
It
phone
just-
goes
you're
out.
right. It's like
So
it
it's
just
like I'm daring to enter this. So if my phone goes out again, you'll know why. Jinx tonight. Okay, so that's here on Earth, right? We even see it here where we have a nice, decently thick atmosphere, and the primary particles, most of them, well, basically all of them, they don't reach the ground. The sad thing at Earth, I mean at Mars rather, is that the atmosphere is so tenuous that the primary particles reach all the way to the ground. And so what ends up happening is that you have cosmic ray showers, not just in the upper part of the atmosphere, but everywhere, all the way to the ground. Okay, because the primary particles reach that far. So what effectively that does is that turns the entire Martian atmosphere into this big polar cap absorption event. Except it's not polar cap, it's everywhere.
yeah.
There's no magnetosphere at Mars to guide the particles into the poles. Mars's magnetic system is a remnant field, much lower in strength, but it's also remnant because it's remnant in the rocks. Because Mars used to have a magnetic field and now no longer does, because its iron core has solidified. Right, that's what Earth's future is going to look like, is Mars. Right? You always heard that phrase: Venus is Earth's past and Mars is Earth's future.
Yeah. Yep.
Solar dynamo, right? I mean, a solar dynamo or magnetic dynamo. Okay. At any rate, because it's just a remnant field, the magnetic field is kind of all over the place. So particles can penetrate to the ground everywhere. So think of a polar cap absorption event that covers the globe. This basically makes the atmosphere completely opaque to radio propagation.
Okay. Yep.
And not just skywave. I mean, it makes it tough to see satellite signals. So the problem that we're going to have is that when you get a big radiation storm on Mars, you're not going to have any communication to, if there's a GPS or a Mars, version of GPS out there, you're not going to have any communication to it. What you're going to need are base stations on the planet itself to be able to do over the horizon communication. And obviously, as I've told the amateur radio crowd, as they call themselves Elmers, the ones that are, and it's a terrible name, but Elmer is an older amateur radio operator, a skilled amateur radio operator, who then teaches a young amateur radio operator how to become one, or even helps someone who's never been one become one. They call them Elmers. It's like their mentor. Okay?
Yeah. Yeah.
And so I've told amateur radio operators here on Earth, I said, we're the Earth colonists. But you have to understand that, you may think amateur radio is a dying art, but in actuality, you're the Elmers to the Mars generation. Because we're going to have to learn amateur radio on Mars. Now, the frequencies will be all different, but it is possible. We've already, lots of military folk have actually done master's theses on whether or not HF radio propagation is possible on Mars. And it is. But between skywave propagation and direct communication, ground wave, what we call ground wave communication, those are going to be it. So you're going to have repeaters, very similar to the repeaters that we have here.
Okay.
And you're going to likely have people with these handheld radios. Sorry, I don't have my Yaesu with me, but you'll have people with these, right?
Yep.
This is a bow phone, probably will be Chinese. So
Yeah.
you'll have people with, these, and then towers sitting on somewhere that they build. And if we want to colonize Mars, that may be the case. So that's for communication. The big issue, of course, is the softness, the radiation softness of the human body. We are not going to be able to live above ground. We're going to have to be likely below ground. I don't even think living in a fissure or a deep canyon is going to be enough. And the problem with that for me is not so much humans living underground in lava tubes, but if we plan to colonize the planet, how are we going to grow food?
Mm-hmm.
Do you think plants can handle a radiation dose up there on the surface? Not a chance. So how are we going to grow food? We're going to need to have electricity and light, artificial hydroponic.
Yeah.
That's a big deal. So to me, that's even a bigger deal than the radiation dose that the astronauts carry there and back, is how do you sustain long-term life on Mars if you can't grow food?
Right. Yeah. So, yeah, there's some big questions. I know even just the little bit that I've learned about this stuff, I'm like, I don't need to go to Mars.
No.
Like,
Neil deGrasse Tyson, let him go, let him go, let him go.
yeah, it's like, I don't need to go. I've seen pictures from there too. I'm like, I'm good. I'm good right here.
Nothing grows there. I mean, that should be the
Yeah.
first hint. Is anything green there?
Yeah.
Is there anything but
Nope.
dirt and rocks? Right? Nothing there but dirt and rocks. Why is that? Because everything there dies. Why do you think it dies? Maybe
Yeah.
because it's hostile to life. And it's not just the atmosphere. Oh, it's because it doesn't have oxygen to breathe.
Mm.
Are you sure
Yeah.
that's it? But, how many botanists, how many people, plant geneticists, right?
Mhm.
We know of someone who could conceivably do that type of study, but how many people do we know are actually studying that when it comes to Mars? No, they're
Right.
studying radiation. They're studying the path, the trip there and back. They're
Yeah.
studying how to create energy and power to, power their above ground domes. And it's like, guys, why don't we talk about food?
Yeah, it's like
Food.
Yeah, and growing plants at ISS is not the same as growing plants at Mars.
Exactly.
Yeah.
It's not even the same as growing plants on the moon, because the moon has got, if you have a radiation storm hitting the moon, right, there's absolutely no atmosphere at all. So you're
Mhm.
not going to get cosmic ray showers unless you're getting neutrons liberated from the regolith itself. And that's another problem that we don't even touch on. But the regolith itself is an emitter when you get radiation storms hitting
Mhm.
planet. I know that in Lunar Reconnaissance Orbiter, LRO, there's an instrument on board it called Crater that was created by Aerospace Corporation, my old
Mhm.
my old group, SSAL. And I remember talking to Bern Blake, who I don't remember if he was the PI on the instrument or just one of the team members, but he said, "Man, it's crazy how big the neutron albedo is on the lunar surface." And he told me about it. I mean, he was actually a nuclear physicist. That's how he got started in doing space stuff, because they didn't know what to do. They knew space was radioactive. So let's put nuclear physicists. Hell, hey, you're now you're now a space physicist. You've been christened space physicist. I'm like, I'm a nuclear physicist. But, that's what they did back then, because they didn't have anybody else to fill the shoes. So Bernie Blake, who was just incredibly good at materials science and how radioactive particles decay, and he was fascinated by the lunar neutral, the neutron albedo. Neutrons are particles that go through everything. It's really hard. You need layers of brick to stop them, and so they're very dangerous from a perspective of human dose.
Mhm.
And to think that if the moon is giving off that much of a neutron albedo, that a spacecraft orbiting the moon registers it.
Yeah.
What is it going to be at Mars, right?
Right.
What is it going to be when astronauts or people have to live, and what in the farm and the plants have to grow out of this stuff? I think these are questions that just have not been asked.
Yeah. I don't think so either.
I mean,
So.
I even asked a team member just last year,
Mhm.
when they were talking about landing astronauts on the moon and dealing with radiation storms. And I said, hey, have you considered the fact that the tools that you're going to be using will get hot from
Mhm.
these radiation storms?
Mm.
And what I mean by hot is radioactive, because the particles are going to hit these metals and they're going to cause the metals themselves to become, or whatever tools they're using, they're going to cause that material, whether it's a shovel or anything else that they're using to excavate anything, it's all going to get radioactive. And I said, have you ever considered the dose from that and how to take precautions? And the guy just looked at me, total
Yeah, like
lead of the program, just looked at me and blinked. And he,
it's like, oh
and
no.
he goes, wow. And he goes, thank you for saying that. He says, I'll be honest. He said, we've never even thought of it. And I just kind of went, yeah, I bet. So, you know, and I learned all that stuff from Byrne.
Yeah.
And that's why I know it, because he was, you know, I sat right next to him at Aerospace, and the guy was just, I mean, he had forgotten, sadly, he's passed away now, but he had forgotten more than I've ever known about nuclear physics and material physics. And so
Yeah.
I learned a lot from him. I even have a couple of his books still. And people that are doing this stuff, they don't have the right expertise to know everything that they're going to come across. And it's going to bite them in the butt, especially when it comes to Mars.
Yeah.
And the only way we're going to figure that out likely is just to go do it.
Yeah, just go do it and
do it and fail.
Yeah, and that's and there are people that are, you know, I mean, that's how a lot of things happened in the past. It's like you think about I always think about this a lot, like especially history. It's like, you know, people that decided I'm just gonna walk west and see what's out there.
Yeah.
But like, you know, and there's people that are driven by that. And it's like, you know, and more power to them. I'm not one of them. But that's you know, that's how we discover these things, is these people that have that drive to, you know, see these unknowns.
Right.
So
and yeah, I don't want to solve the problems. I'll solve them on the fly when I get there.
yeah. Yes.
Go to Mars. Go ahead. See how easy that is at Mars, you know.
Yeah.
But those are my big concerns as we become a, you know, a spacefaring species.
Yeah.
We're gonna, just like in aviation, right? All the laws are, all the rules and policies written in blood, because they didn't exist until somebody died.
Yeah, till somebody unfortunately saw what happened.
You know, it's like, oh, maybe we shouldn't do that again. Right.
Yeah.
You know, if we had a you know, any foresight at all, we would be doing this the right way. And the thing is that Earth gives us a lot of these answers, because Earth is dealing with it day and night, right? It's dealing with radiation storm. I'm seeing a polar cap absorption event occur right now. I'm looking on my ham clock.
Yep.
I see it. And so, you know, the answers are here. We just need to know how to ask the right questions.
Yeah. And that's a excellent way to wrap this all up.
Oblige.
Yeah.
Yeah, this has been a long time. It's almost
almost 3 hours. Yeah.
It's like one of my mini courses, guys.
You're just so, you know, you're just a fascinating person to talk to. And, you know, it's like, I just love like your perspectives on things, because it gets me to think about things differently. And so that's what I've always appreciated about you in general. And just and like I said, the way you can describe things, you know, it makes it accessible, and where I'm not like looking at a page of math equations and be like, I can't do this.
Yeah.
And it's like, yeah, and then you just get turned off by it.
Right.
So yeah, so I will always appreciate and admire that about you.
Oh, thank you. I think and both of you guys do a lot of the same, you know. You spread the love and help other people, you know, change their perspective, or at least ponder questions that they hadn't ever pondered before.
Yeah.
And I think that's really the key, right? Just getting them to think in a different way. Sometimes it just takes a little bit of a, you know, shift your head this way, and like, oh.
Yeah. It's like, wow. Yeah.
Yeah, I never looked that way. I only look this direction. No, shift over. There's the whole world over here. I hadn't looked. So you know, so it really helps that you guys are so passionate about what you do as well. And I know that you're doing the same thing. As much as you say I'm inspiring you, I know you guys are inspiring others. I mean, look at this podcast. Right?
Yeah. I know this little project that one day I'll get to, you know, I'll get better at the tools to do it. But for now, I mean, it works for now. So it's all good.
It's wonderful. It's wonderful. And I appreciate, and I'm sure you'll hear that from people and say, oh, yes, you guys absolutely do. I can't wait to tune into this, you know. And that stuff, irrespective of who the guest is,
Mhm.
because you guys make it fun, and that's all anyone can ask of us.
Yeah.
As we, try to spread the love of what space weather is and
Mhm.
isn't, right,
Yeah.
and try to navigate some of these sometimes turbulent waters.
Yeah, that's
with
for sure.
the
Yeah.
landscape of AI and grifters and
Yeah.
all of the other things that kind of come up. We just kind of dodge these bullets and keep on moving.
Yeah, keep on trucking.
That's right.
So,
That's all we can do.
so before I cut it off, I'll ask, are there any questions that people have? Because I know we have Christian monitoring.
So Janelle wanted me to ask Tamitha if she had anywhere where she could watch the heliobiology information or lectures that you have online.
I have not lectured about heliobiology as a single subject.
Okay.
Sadly, the parts where I talk about heliobiology are interspersed in other, lectures that I've done in other classes. And
Okay.
the reason for that, sadly, and I've been talking to my Patreon family about that. And I've been told that I have to be very careful, because heliobiology is such it's a new science, and it's still very hotly debated. And so there's a credibility issue. We have to be very careful when it comes to that. And being a scientist that, really wants to stay with the truth, I don't want to get over my skis when it
Mhm.
comes to that. But I think I think something like that is coming, because there's so many, there's so many more credible articles that are coming out. And obviously so many areas in heliobiology that are very easy to recognize as being real, right? So we're
Mhm.
not talking about tinfoil hat wearers, we're talking about medical devices, for instance, patient care and safety, right? And with all the different types of cyborg mechanisms we're coming up with now, oh my gosh, look at Neuralink and half a dozen other, I mean, you should see all the things, the inventions coming out of China, all these embedded
Yeah,
devices.
right.
It's scary how fast this field is moving forward. And I guarantee you, none of them have considered what happens when these things get irradiated,
Mhm.
right? Do people suddenly have a bit flip? I mean, what does a bit flip mean to someone with a Neuralink?
That's a good question.
Well, that is a very good question, because the whole thing with cosmic radiation is known to medical devices. And the testing capabilities, there is definitely software part and hardware part that are studied. There's software part, but unfortunately, there are some events that where two bits are flipped and next to each other.
Yeah.
And that can result in really bad outcome. And that actually has happened and was reproduced in the lab. So that's one part. Second part, it really is hard to find similar testing environment on Earth.
Yes.
Those are extremely high energy particles and very different spectra. So trying to stick them into just any type of medical device, because sometimes the proton, um, basically proton, same devices that are used for chemotherapy, for radiation therapy, they're used for sort of testing devices. So you have a proton gun essentially that's pointing a device to see what happens to it. It's not the same as even taking those devices up in the air during radiation storm to see what happens. And it's not the same to see what happens to that device when a cosmic ray shower hits it. So we don't have a way to test it. We might be able to mitigate with software, and a lot of devices are actually coming with embedded software mitigation parts. But as far as the material, as far as hardware part, we really have no way to test it here on Earth.
Right.
So going to Mars is a little exciting, because if they can take devices with them,
Yeah, just
that
take
would
them
be
with. Yeah.
just take a bunch of devices and send them there.
But it's still not going to be the same. We call that
No.
in engineering, we call that test as you fly.
Mhm.
And that's actually when I worked at the Space Environment, that's the SEE lab, the Space Environmental Effects Lab. That's exactly what we did, is we took, depending upon a particular orbit, because all the different orbits have different radiation environments, because there's different populations with different energies. So there's always this spectrum, right? It's not just one energy. It's a spectrum of energies of these different particles in these environments. And we would build up a spectrum, and then we would literally take a gun, and we would layer, because your gun only has one energy. It was monoenergetic beam, but you can then dial in a certain amount of flux and layer in high energy to low energy when you deposit these particles onto, let's say, a witness sample or something that we were testing. And so we would build up that spectrum to try to test as you fly, literally test the spectrum that the material is going to be in, and to see what type of damage it caused. And that is, yeah, it's a non-trivial thing. In fact, there's a huge part of the physical sciences laboratory at Aerospace. That's one of the flagship labs that they have, is the SE lab, because of the care that Mike Mishiznik took building that lab so many years ago. So I got a really good dose of, no pun intended, of how that works and how critical it is. Because most people try to do it through like cobalt 60, or, they do gamma rays, and they try to, or they go to what we call I'll use Mike's favorite phrase, please forgive me if anyone's sensitive to this word, but he called it the Goddamatron. Because it's a particle accelerator that had these particles that were so high energy that it really it overshot the energies that were required to test a particular part. Because sometimes the highest energy particles are the ones that deposit the least amount of energy. It's something called linear energy transfer, and it's the particles that actually stop in the material. They have just enough energy to come to a full stop in the material, that then deposit the most energy, where the particles that are super energetic and just fly right through it, they don't really deposit much on the way through. So all of that factors in, and only people who understand, those nuances can really test things well. So Tanya, you're right on that, all these different types of tests that people do for all these different devices really it's not a one-to-one. And just because you can survive one kind of radiation dose doesn't mean that translates to an equivalent dose in a different environment. Even with like what we call elders, like these are super extremely low dose rates, those cause a different type of effect, and they can be sometimes more damaging. So it's definitely an unknown area. And I don't know, I was thinking, Tanya, when you were talking about the different parts in the double bit flip and stuff like that, some of these people have the Neuralink in them, and they can start controlling their hands again. They're like, oh my God, this is great. And then if they have a double bit flip, it starts.
Yeah, like
So I had that, that was an intrusive thought that came in for a second. So if you saw me smiling while you're talking, that's the only reason why I wasn't going to be.
That sounds like a sci-fi movie right there.
There you go, right there. That'd be a great space fighter. The double bit flip and the Neuralink, and it's like, mutiny, it's attacking me. Okay. Definitely the end. Hopefully that answered Janelle's question.
Yeah. I love how these just take turns. All right. Do we have any more, or can we call this a night? We'll see. He might be scanning it, but
I think we look like we're in the clear.
okay. All right. So we can let everybody have their evening back now. But
or the day.
Yeah, or the day wherever they're watching. But thank you again so much for being here, because this has been, we've been wanting to put this together for a while, because you're just so much fun to talk to. So very much appreciated. And I'm sure everybody listening thinks the same. So thank you again so much.
Absolutely my pleasure. Absolutely.
All right.
You two were great blessed. Thank you so much for hosting me. I appreciate it for as long as you did. Didn't kick me out.
Yeah,
it's a pleasure.
Yeah, so it's all good. All right, so I will say bye to the YouTube.